Hello students, welcome to the class. So today is our day 25 of this JEE 40 days crash course and we will be starting with a new chapter which is coordination compound. Now this coordination compound has a very deep linkage with the chapter D and F block because here we deal with the complexes that are formed from the D block elements. Okay. So this is our disclaimer. If I talk about the weight percentage of this chapter, so there is a total weight percentage of 4.58, and from your inorganic chemistry, this is the most important chapter. At least one question is being included in every year in the JEE question paper, and from 2017 to 2024, 11 questions were being asked. Next, what are the important topics? So the most important topic is your CFSC, which is your crystal field destabilization energy. Then we would see questions from nomenclature and isomerism, and lastly from the Werner's theory. So you would clearly see that there are questions from in 2024 from bonding and coordination compound, that is again mostly explained by the say your crystal field stabilization theory. Then one more important point. So from this part also we see the questions of magnetic movement. Okay. So in 2023 again we can see questions from importance and application of coordination compound. Then in 2022 we are seeing it from CFSC, metal carbonyls and IUPAC. Moving on to 2021, again we can see questions from magnetic properties and your isomerism part. Next, regarding 2020, 2019, 2018 and 2017, we can see questions from magnetic movement primarily, then from CFSC and your metal carbonyls. Got it? Questions from Werner's theory is rare. We won't see much questions from that part, but it is very important. Got it? It is very important because it helps you to build the basic of this chapter, which is coordination compound. From here only you will come to know that what is primary valency, what is secondary valency and so on. Now moving on to today's topic. So first of all we will start with the Werner's theory. Then we will move on to the nomenclature of the coordination compound according to the IUPAC. So two parts are there regarding the identity of your compound, coordination compound. Two parts are there. First is your IUPAC and second is isomerism. So we will cover both of the parts. So today we will not move on to the bonding part where we will try to explain the bonding in your coordination compound using your valence bond theory and your CFSC. So that will be dealt in the upcoming next class. Coming on to this isomerism. So we can see that we have stereoisomerism and your structural isomerism, then linkage isomerism, coordination isomerism, ionization isomerism, and solvent isomerism. I will try to explain each of these types of isomerism in coordination compound. So they are very simple and questions are mostly asked from this stereoisomerism and optical isomerism. Okay. Then important part of this, as I said, was nomenclature. Now nomenclature is important in two ways. First of all, there would be direct questions from the naming part, or else the name of the compound would be given and the subsequent question would be asked regarding that name. So if you know the name and the structure, then and then only you will be able to solve the question. Okay. So if you don't know to write the name of the compound, you won't be able to solve it, although you know about its magnetic movement or its isomerism or any other property. So this nomenclature is kind of very important. Starting with the Werner's theory. So if I talk about coordination compound, then they are molecular compound which do not lose their identity if they are being dissolved in the water. Okay. So if you compare it to other species such as NaCl, which is again a salt, but if you dissolve it in water, its identity is lost. You get a different kind of species, which is your sodium plus and a chloride ion, which is totally different from the initial form, which was your sodium chloride salt. But this is not applied for the coordination compound. Now, in these compound, your metal ion is bonded to a number of neutral and ionic species, and they are bonded together by coordinate bond. So you have three types of bond basically. The first one is ionic, then you have covalent, and this one is known as coordinate bond. Now, if I talk about the dissolution of it in water, then upon dissolution, the complex part or the part which is close together by the coordinate bonds are intact in the water solution as well, whereas those we are intact together by the ionic bond are dissociated into the solution. For example, if I take K4FeCN6, so this is a very classical example of coordination compound. Here we have two parts. One is your K4, which is your ionizable part, and the second one is your non-ionizable coordination sphere. So coordination sphere is very simple. It is a square bracket within which both your metal ion and your ligands are present. So this Cn is your ligand and this Fe is your metal ion. Now, if I talk about its dissociation in water, then upon dissociation it gives us 4 molecules of K plus and 1 molecule of FeCN whole 6 4 minus. So this part that you are seeing, this is something which is not dissociating upon dissolution in water, whereas this part is being separated from the main part, which is your 4K plus. So that is the reason we are calling it as ionizable, means it is converted into ions. But this part isn't intact, okay? Although the K4 is removed from it, but this is intact in the water solution. You will not see that we are getting the Fe3 plus and Cn minus ion. Okay, so we will not see that 6 Cn minus ion has been removed from the Fe. It will be connected to the Fe instead of although it is dissolved it in water. Got it? So this is the important point regarding your complex ion, and from this part you will also see questions from the solution chapter. If you have done numericals on the same, you must have encountered questions from here. So if I ask that what is the I factor, which is your Ventov factor for this particular complex, then you will tell that since 5 species are obtained, 4 of K plus and 1 of this complex, therefore the I factor would be 5. Okay, so you know it, what is I factor and all. I factor is basically the number of particle after dissociation divided by the number of particle before dissociation. Before, this was a complete one complex, but after dissolving it in water, we are getting 5 particles. Therefore, the I value is 5 in this case. Okay, is it clear? Now, we will talk about the internal parts of the coordination compound one by one. The first one that we will study about is the coordination entity. Before moving on to that, I would like to take a moment and appreciate the work of Alfred Werner. So in 1982, he was the first man to study about the bonding in your coordination compounds. And his main postulates were, first, your complex compound shows two types of valency. One is your primary valency and the other is your secondary valency. So what is primary valency? If you have looked upon the previous example, we got two different type of entity upon dissolving it in water. The first entity was separated from the main part. So that is something which is ionizable, 4K plus. So here the 4K plus is completing its primary valency, the primary valency of the complex. So we call it as the primary valency, and it is simply the one which is clearing or neutralizing the oxidation number of the central metal ion, so that the overall complex is neutral, and it is not the part of your coordination sphere. It is outside the coordination sphere. You must have seen the formula. It was outside the square bracket. So those type of ions which satisfies your oxidation number and is present outside the bracket is known as the one which is primary valency. So in the previous case, the primary valency would be 4 because 4 K plus ion were present. Then if I talk about the secondary valency which is present inside it, so these are the species which are connected to the central atom upon dissolution of water also. And in the previous example, if I consider, which is K4FeCN6, so the 6 Cn ligands are the one which are satisfying the secondary valency. So in this case, your secondary valency would be 6. So your primary valency would be 4, which are ionizable part, and your secondary valency will be 6, which are non-ionizable and are attached to the central atom upon dissolution in water. Now, if they are ionizable, means they are kind of ions. So they are attached in a way your ions are attached. And you know it very well that ionic bonds are non-directional in nature. Okay. So they are non-directional and ionizable. Whereas your secondary valency is First of all, non-ionizable, but it is directional in nature. Means the ligands, the 6 ligands of your cyanide, which is CN, are arranged in a particular manner. So it may be octahedral since the coordination number is 6. It depends on the compound, and therefore it gives shape to your complex. So what would you remember? First of all, primary valency are ionizable in water, means they dissociate in water after dissolving it in the aqueous solution, and they are non-directional, means they are not present at any specific angle. Whereas your secondary valency is something which is not ionizable, and they are providing a specific shape to your given complex. Is it clear to you? So if we take the example of CrH2O whole 6 and then Cl3 is present outside, then the primary valency would be 3 because there are 3 chloride ions that are present outside the bracket. Whereas your secondary valency would be 6 because 6 water molecules are attached to the chromium ion. Is it clear to you? So this is very, very important to understand the difference between your primary and secondary valency. Got it? Next. So here are some important terminologies regarding the coordination compound. The first one is coordination entity. So what are coordination entity? So it includes both your metal ion and the ligands which are satisfying your secondary valency. And there are 3 types of coordination entity. First one is anionic complex. So if your complex is having a negative charge, we call it as anionic complex. For example, this 3K plus and FeC2O4 3 minus is an anionic complex. You can see here it is having a negative charge on the top, right? Upon dissolving it in water, we are getting a complex which is having a 3 negative charge. Therefore, this is an example of anionic complex. So it's very simple to understand. It's a very general classification. Now moving on to the next coordination entity, which is your cationic complex. So of course it will carry the positive charge. Can we take an example of it? Yes. So we are taking COCl2 En2Cl. You won't be don't worry about the terms like En and all. We will cover this when we will see the ligand and all. So this is basically your ethylene diamine. So in between we have 2CH2 and on the terminal part we have NH2 attached to it. So this is your ethylene diamine short representation. So if you dissolve it in water, the Cl minus will be separated from it, and we will see that the complex is having a plus charge on the top. So it is an example of cationic complex. And lastly, we have some neutral complex that do not carry any charge. For example, if you take the example of NiCO whole 4. Now in this case, your carbonyl, which is your CO, so this is a neutral ligand. If you compare it with the Cl, which is your chloride ion, so it is a negative ligand. Of course, it is a negative ligand because it will complete its valency only when it will have a negative charge on it. Whereas your En that you are seeing here is a neutral ligand. We'll talk about this, what are neutral ligands and what are ionic and what are anionic ligands. But before that, to justify that this is a neutral complex, you must know that your CO is a neutral ligand. It is not carrying any charge on it. Okay. And since the charge on it is 0, so there would be no charge on Ni as well because overall this complex is neutral. Therefore, this complex is having a 0 charge on it, and we call these type of complexes a neutral complex. You will mainly see neutral complexes are formed with the help of this carbonyl ligand. Okay. Next is your ligands. So what are ligands? This is something which is very important to understand. So how do ligand participate in bonding, in coordinate bonding? How do they do it with the metal ion? So basically they donate a pair of electrons to the metal ion. In your normal bonds, you would see that both the species are donating one electron and then we are forming a covalent bond. But here in this bond, your one species is only donating electron whereas the other one is getting that. Okay. So these type of bond is known as your coordinate bond, and it is shown by the ligands, which can be ion or a molecule, and it is surrounding your central metal ion. Now talking about the denticity. So denticity is the number of donor groups which can bind to the central atom. Okay. So in a given single ligand, there can be multiple sites which are available for making coordinate bond with the metal ion. So that number is known as denticity. Now on this basis, we have different kinds of ligands. So first is your unidentate ligand. So in this case, your donor atom count is 1. For example, if you take the case of H2O, so H cannot donate electrons because it has no lone pair on it. The oxygen has lone pair on it. So this oxygen can donate a pair of electron onto the metal ion, and hence it is a unidentate because it is donating electron through one single site. Similarly, this NH3 also is donating electron through a nitrogen only, and same can be said about carbonyl or Cl minus or NH2 minus. So all of them are unidentate ligand because they have only single site of donation. Then if we talk about didentate ligand, so here the number of donor atoms are 2 or the number of donor groups are 2. For example, if we take the case of oxalate ion, which is C double bond O, O minus. Here also we have C double O, O minus. So this is your ethylene diamine, which is represented by En. Okay, so rather than writing the whole name in the ligand, we use the short notation En for this complex, for this ligand. Now both of these ligands can coordinate through two sites. If you consider the oxalate ion, it can connect through this upper oxygen and this down oxygen. Similarly, this ethylene diamine can do a coordinate bond with both of the nitrogens, and hence these two are the examples of didentate ligand. So in this case, the denticity of these two species is 2. Okay, so it is as simple as that. The number of groups which are capable of making bond is known as the denticity of a particular ligand. So for H2O, NH3, CO, Cl minus, NH2 minus, all have a denticity of 1, whereas your C2O4 minus or ethylene diamine both have a denticity of 2. Moving on to the next, we have polydentate ligand. So apart from number 1 and number 2, all the other species are kept under this polydentate, means they can chelate through a number of sites. For example, we can take the example of EDTA, known as ethylene diamine tetraacetate ion. In this ligand, there are 6 sites that are available for donating electrons onto the metal ion. Therefore, we put it in the polydentate ligand. If you want, you can call it as a hexadentate also, since the number of donating sites is 6. Moving on to the next type of ligand, which is known as ambident ligand. Now, what are ambident ligand? This is interesting to understand. So these are a kind of ligand that are unidentate but can donate through 2 parts, okay, but one at a time. So basically, there are 2 donation sites, but it can donate from one at a time. Got it? For example, if we take the case of NO2, so there are 2 possibilities. Either it can make a coordinate bond with the help of oxygen or with the nitrogen. But if it is making a bond with oxygen, then it will not make a bond with nitrogen. And if it is making a bond with nitrogen, it will not make it with the oxygen. Similarly, your SCN also is a ambidentate, which can chelate through 2 sites. Now, next is your chelate ligands. For this, you have to take the example of oxalate. So if your oxalate, which is your bidentate ligand, if it makes coordinate bond through both of the oxygens, so your C2O4 minus that we have seen in the previous page. So if that ligand makes coordinate bond through 2 sites, so that would make a complete ring. Okay. Now that ring making is known as chelation. So let me clarify it for you. So these are bi or polydentate ligand that forms a closed ring with the metal ion. And your chelate rings that are formed are very, very stable. And this is so much stable that your unidentate ligand can be removed with the help of chelate ligand. So if there is a reaction, you can remove your unidentate ligand with the help of this chelate complex because of the higher stability. Is it clear to you? Any doubt in this? So you must understand what are the types of ligand. What is unidentate, what is bi, what is poly, what is ambidentate, and what is your chelate ligands. So chelate ligands are those which can form a ring with the metal ion. So for example, if you take the case of oxalato ion, if it is forming the coordinate bond with both of its oxygen, then it will make a ring. Which membered ring? Of course, 3-membered ring in which I would put 5-membered ring in which there will be 2 carbon, 2 oxygens and 1 metal ion. Okay. Any doubt in this part regarding the ligands? So I would suggest you to remember that whether a given ligand is unidentate or bidentate or polydentate, and also classify that it as ambidentate and chelate. So you must know that whether the given ligand is what and what is the characteristics and where is the donor site. Okay. So if you have a doubt, you can ask it in the comment section now. Okay. So moving on to the next. Then some more important property terms, we have coordination number. So coordination number, which is something that can be calculated by calculating the number of ligands that are present or that are directly attached to the central metal ion. So if I consider the case of monodentate ligand, then it is very simple. You will simply count the number of ligand and that would be the coordination number of the given complex or metal ion. But if I take the case of bidentate ligand, then in that case it would be twice the number of ligand. Suppose if your metal ion is connected through 2 oxalate ion. Okay, since the number of ligand is 2, but the coordination number would be 4 because each oxalate ion is connecting through 2 atoms because of its bidenticity. For example, if I take the case of AgCN hold 2, then with a negative sign, then there are 2 unidentate ligands, both are CN. Therefore, the coordination number would be 2. But if I take the case of this oxalate ion, 3 oxalato ions connected to the iron, then there are 3 bidentate ligand. That would be 6 connections with the iron of our ligand. Therefore, the coordination number would be also 6. Okay, so it is not dependent upon the number of ligands for bidentate and polydentate ligand. For that, you have to count the number of donor sites. For example, here there are 2 donor sites for 1 oxalate ion and 3 such oxalate ions are present. Therefore, the coordination number of iron in this case is 6. Next, we have coordination sphere. So we have talked about this coordination sphere. So this is inside the bracket and includes your central ion as well as the ligand which are directly attached to it. And together they are known as the coordination sphere. Now, what about the ionizable groups? So they are always written outside the bracket and they are known as the counter ions. So we have two parts. One is your coordination sphere, which includes your metal ion and the ligands. The other part is your counter ions, which are present outside the square bracket and are helping in balancing the charge. Got it? Okay. For example, if we take the case of CuNH3 whole 4 SO4. So here the SO4 that is present outside the bracket, that is your counter ion. Whereas the square bracket entity, which includes a 2 positive charge, is your coordination sphere. It includes the metal ion as well as the ligands. Now, moving on to the next important term, which is coordination polyhedron. So I've told you in the start that secondary valency is directional in nature and their arrangement in the spatial region helps in determining the shape of a given coordination complex. So this spatial arrangement of the ligand in which they arrange in certain geometries is known as the coordination polyhedron and it is around the central atom or the ion. Now, next is your oxidation number. Now, this terminology is very, very important and you should know how to calculate the oxidation number of any metal ion in a given complex. So, how you would do it? It's very simple. It is the charge that it would carry if we calculate it by assigning the appropriate charge to the ligand. So, you know how to assign the oxidation number and then you will make the charge equals to the charge on the complex. After that, you can calculate the charge on the central metal ion. Okay. For example, if I take the previous example of FeCN6 whole 4 minus. So the overall charge is 4 negative. So you will make it equals to 4. On 1 Cn we have 1 negative charge, therefore 6 negative charge. And consider that the iron is having X charge. So minus 6 plus X is equals to minus 4. So that would give you a overall charge of plus 2 on the iron. So you know how to calculate the oxidation number. You will use the same method here. After that, we have homoleptic and heteroleptic complexes. So it's very simple. If all the ligands of a given coordination compounds are same, then we call that given complex as homoleptic complex. For example, your cobalt with 6 amine R is an example of homoleptic cleavage because all the ligands are same as amines. Then next, if we take the example of heteroleptic complex, then we can take CONH3 whole for Cl2. So here we have two types of ligands attached to the cobalt. One is amine and the second one is chloride. Therefore, we call it as the heteroleptic complex. This is very simple to understand. Now, we will move on to the nomenclature. So we are already now aware about the important terminologies that are related to coordination compound. Therefore, we can now see the rules to name it. So in all the complexes, so whether it is positively charged or negatively charged, we would first name the cationic part. Okay. Now that can be counter ion as well as the complex. So where the counter ion is playing the role of positive charge. For example, in the first example we have potassium ion. So there we have used K4 plus, 4K plus, and the rest part was FeCN6 whole 4 minus. So from that it is very clear that the cationic part is your counter ion and not your complex part. So we will first name that potassium. Okay. Next, we will name the ligands. How do we name the ligands? It's very simple. You have to name it according to the charge which is assigned to it, and then you will place them in the alphabetic order. Now, how do we decide that what is the name according to the charge? It's very simple. If your ligand is anionic in nature, if it is having a negative charge, your name will end with O. For example, your chloride ligand will be named as chlorido. Got it? Similarly, your nitrite ligand will be ended as nitrito. Easy to get. But for the neutral and cationic ligand, we don't have such complications. Okay, so this is only for the anionic ligands. Now, apart from the name of the ligand, we also use some special terms for some special ligands. For example, for H2O, we don't use the term water. Rather than that, we use the term aqua as the name of the ligand. Similarly, for NH3, we don't use ammonia, we use amine. Then for CO, we don't use carbon monoxide, we use the term carbonyl, and for NO, we use the nitrosyl. Okay, so this is very important for your neutral ligands. So what did I say? You have to simply use the name of the ligand to name the compound. If it is anionic in nature, you have to place a O at the last. If it is neutral or cationic, you will use the same name, but there are some special cases such as aqua for water, amine for NH3, carbonyl for CO, and nitrosyl for NO. Next, if the counting of the ligand is more than one, we use the term mono, di, or tri, or tetra, depending upon their count. But we will not use them while placing them in the alphabetic order. Okay. But there are some cases where your ligand has already this mono, di, and tri. In that case, you will use the term bis, tris, and tetra case to indicate their count. For example, ethylene diamine has already di in its name. Yes. So in that case, if 2 ethylene diamine is present, then you will name it as bis ethylene diamine. Or if 3 are present, you will use the term tris ethylene ditetraamine. So this is the important part. You should remember it. Okay. So if your name is already including the mono, di, and tri in its name, then you will use bis, tris, and tetra case in place of mono, di, and tri. I hope this part is clear to you. And remember, while placing the ligands in alphabetic order, you will not look at these starting terms like your M of mono, D of di, T of tri. Rather than you will use the actual name of the given ligand to place them in the alphabetical order. Is it clear? Okay. Now, what about the oxidation state? So always remember that you have to write the oxidation state of the metal ion which are present inside the coordination sphere after their name. Whether it is anionic, cationic, or neutral, doesn't depend on that. You have to always give its oxidation number in the Roman numerals in the parenthesis. Then after, if your complex ion is cationic, the metal is named in the same way. But if your complex ion is cationic, suppose if I take the case of the first example where your anionic complex was present, FeCN6 whole 4 minus, then in that case, you will use the suffix ATE. But for some metals, we have to use a different name. Like your iron, you can't name it ironate, rather than you use the term ferrate. Okay, got it? Similarly, for tin, you will not use the term tinnate, you will use stenate. And this is for which metal ions? This is for those metal ions which are present in a cationic complex part. Okay. Lastly, the neutral complex molecules are named similar to that of the complex cation. So for the neutral complex also, we use this same thing. Is it clear to you? So for anionic, for your anionic part, we don't do anything. For a cationic part, we don't do anything. But for your anionic complex or your neutral complex, we use this thing ATE as the suffix, like your ferrate, tinnate, stenate, and all, and cobaltate. So this is very important to remember. Now, moving on to the types of isomerism. So this is the last thing that we will study. So first we have dealt about the important terminologies. Then we moved on to the next part, which was all about your naming, and the third part is your isomerism. So what is isomerism in simple terms if I define? So these are those species which have the same molecular formula but different structure or different spatial arrangement, and due to this they have different physical and chemical properties. Okay, so these kind of species are studied under the name isomers. Now there are mainly two types of isomerism. The first one is the stereoisomerism. So in this case, it is basically arising due to the different spatial arrangement of the ligand around the central atom. So it can be of two types. First is geometrical and the second one is optical. What is geometrical? So it arises mainly in the heterolytic complexes where two different geometries are possible for the same kind of ligands present around the central metal. Okay, and the important examples of this behavior is mainly illustrated through the square planar complex and your octahedral complex. Your tetrahedral complex has no tendency to show this geometrical isomerism. Next, in square planar complex, we can take some example like your MX2L2. So here it is a square planar complex where the shape is square planar, and the two ligands X can be present on the same side and on the opposite sides as well. So they can be present adjacent to each other or opposite to each other. So this will give rise to two types of geometrical isomerism. If they are present adjacent, means next to each other, we call it as cis, and if they are present opposite to each other, we call it as trans. Suppose we take PT in the between and both Cls on the left hand side and both NH3 on the right hand side, then that would be an example of cis. But if we take PT in the middle and NH3 on the diagonal part and Cl on the diagonal part, then it would be a trans. Okay. Moving on to the next, we have this square planar complex. So what second type of square planar complex, which is of MAABXL type. So in the previous case, we have only two types of ligand. So that was represented as Ma2B2 or Ma2X2. You can take any notation for it. But in this case, all four ligands are different. So in this case, we can take the example of PTNH3BrClPy. How we will draw different geometrical isomerism? So you will keep the one part as constant and try to rotate the other. So that would give you three types. Okay. Three geometrical isomers are possible for the type of MAABXL. Means for these particular species, three geometrical isomers are possible, and it's very simple to draw. You keep NH3 constant and try to rotate the other three, and you will get three different type of species. So this is a way you can remember it also. Then we can move on to different type, which is MXL whole twice. So here XL is what? XL is one specific ligand, but it has two donor sites which are different. Like in the case of your oxalato, your both donor sites were same. But we can take a bidentate ligand where the donor sites are not same. Like this glycinato. Okay, so here the two donor sites are nitrogen and oxygen. Now if both of the bidentate ligand are present in a symmetrical manner, then you will get a cis, and if they are present in the opposite part, you will get it as trans. Suppose I place the M here. Now XL is the bidentate ligand, so there is one X and there is one L. In the opposite side, we have the other the second XL. So X is present on the top and L is present on the downside. So this is an example of what? This is an example of cis. Then the other one would be what? We will change the donor side setting. We will bring X to the down and L to the up. So that would give rise to the cis one. After that, we have octahedral complex. So octahedral complex are also capable of showing this geometrical isomerism. So the first type that we are taking is your MX2L4. What is that example? MX2L4. So one of that example of that MX2L4 is CONH3 whole 4 Cl2. So here also we have two different scenarios. If we keep NH3 adjacent to each other and Cl adjacent to each other, then that would give rise to cis, where your remaining NH3 are present axially like this, and your remaining 4 are present in the same plane of the square planet. So overall it is octahedral. So 4 will be present on one plane and 2 will be present axially. So in that case, if we take NH3 on the adjacent side in the same plane, then we call it as the cis one, and if they are present on the opposite side, we call it as the trans one. Lastly, we can also have octahedral complex showing geometrical isomerism of the type MX2A2. So here X2, in this X is a unidentate ligand and your A is a didentate ligand. So they are also capable of showing the geometrical isomerism. Okay. Is it clear to you? So we can take the example of COCl2 EN whole twice. So EN is a symmetrical didentate ligand. So this is capable of showing what? Geometrical isomerism. Any doubt in this part? So I am giving you a task to try to draw the geometrical isomerism of each type. So we are given with the example. Just try to draw the possible number of geometrical isomers. Here the count is already given. So I am telling you the count. For example, for this E, there will be 2 geometrical isomerism. Similarly, for D also we have 2. For C, we will have 2. For B, we will have 3. And for A, we will have 2. Just try it for each of this example and see that whether you are able to draw the geometrical isomerism or isomers or not. Next, we have the other type of geometrical isomerism in Ma3B3. Here, we are taking CONH3 whole thrice, NO2 whole thrice. But in this case, we don't get cis or trans. Here we get the facial and meridional. Now, this name is very much literal. So whenever the 3 ligands forms a single face of the triangle, we call it as the facial, or else we call it as the meridional or mer. For example, if we take Ma3B3 type here, you can take any ligand here. So A as one ligand and B as the other. Similarly, in this case, if you take the first example, then in this case, the A that are present on the same plane and the one which is present axially, these 3 can form a triangle. Okay. So this will be the facial because it is forming a face of the triangle. Whereas these 3A cannot form the face of a triangle because they are present on the same plane, and hence we call it as the meridional. Got it? Is it clear to you? So it's very simple to understand. If they are present 180 degree to each other. So if you take the case of facial, every A is present at 90 degree to each other. Same can be said for the B. But if you take the case of this meridional, then in this case, your 2 B's are present at 180 degree. And similarly, here the 2 A's are present at 180 degree. Therefore, this is meridional. Got it? So in this way, you can differentiate between the facial and meridional isomer of the given octahedral entity. Next, if I take the example of MA3, MA6, MA5B. So here MA6 is the example of 6 unidentate ligand. MA5B is the example of 5 unidentate ligand of the same type and B of the other type. And this is an example of bidentate ligand but having the same donor site. So 3 is the count here. So all of these 3 types are not capable of showing geometrical isomerism. Moving on to the next types of isomerism in coordination compound is the optical one. So first we have studied about the geometrical, now we'll study about the optical. So what are optical isomers? So these are formed by those species whose mirror images are not superimposable on each other. Okay. So basically, if you take the mirror image of a compound, if you try to superimpose, you won't get the same compound or the linearity. And these two species that you got upon the mirror image are known as enantiomers. So the most classical example is your hand. So if you take the mirror image of your hand, so it would be other hand. Great. Now try to put them on each other with the same alignment. You will see that it is not possible at all. So these two are the enantiomers of each other. Got it? So similarly, the compounds whose mirror images are not aligned to each other, then in that case, or superimposed on each other, in that case they are known as the optical isomerism. And if there are the mirror image and not superimposable, we call them as the enantiomers. If suppose our hand was in the shape of square rather than the shape that we are seeing, then what would happen? We will get the square on the other side, and in that case both would be impossible on each other. How do you define it? How do we know that the mirror image is superimposable or not? It's very simple. Just look at the plane of symmetry. So what is plane of symmetry? It is something which divides your given image or your given compound into two equal parts. Take the example of a circle. If you draw a line in middle of the circle, you will get two equal halves. So that is an example of a superimposable image, and it is having a plane of symmetry in the middle. Similarly, if you take an equilateral triangle, means all three sides are equal, then you can simply cut it in or bisect it in two halves. So it is also having a what? Plane of symmetry. But instead of that, if you take such a triangle which has three different sides, means all sides are of different length, then in that case you won't be able to cut it in two equal halves. So that is not an example of image that is having a plane of symmetry, and it will have its enantiomer as well. Okay. Now, next is your two enantiomers that you got upon the mirror imaging. They are enantiomers and they have the form dextro and levo. What is dextro? What is levo? So levo, if you pass a plane polarized light through a given compound, and that is enantiomer, and if it rotates your plane polarized light by a degree towards the left, then we call it as levo, and if it is rotating it towards the right, we call this as the dextro. Here we will not go into that technicalities. We will look upon that in the organic chemistry. Our main focus is to see whether your given compound is capable of showing optical isomerism or not, and it's very simple. The most basic idea is to look upon the plane of symmetry in that given compound. So complexes of the type Ma3, Ma2B2, Ma2BC and Ma2B2C2 shows optical isomerism. So remember these examples, and from this, if you just compare your given compound and you see that they are of the same type, then you will clearly say that they will show optical isomerism. For example, we can take COEN whole thrice, which is ethylene diamine, having two donor sites and they are repeated thrice. So this is an optical isomerism, means it can form optical isomerism because their mirror images are not superimposable on each other. Similarly, the PTCl2 En whole twice 2 plus, this is also an example of compound which can show optical isomerism. Next, if I talk about the octahedral complexes of the type Ma2, X2, Y2, they can show both optical and geometrical isomerism. So this was all about the optical and geometrical isomerism, which concluded our stereoisomerism. Now, next, we will look on to the structural isomerism. So this is the next type. It is of different types. The first one is linkage isomerism. So what are linkage isomerism? In this case, the linkage of the particular ligand is changed, and it can only be shown by a complex if it contains an ambident ligand. For example, here if we take the example of CONH3 whole 5 NO2 Cl2, then your NO2, you know it very well that it is an ambident ligand, as it can chelate through two different parts. It can chelate through nitrogen or through oxygen. So if it is coordinating through nitrogen, we will get one of the isomer, and the other one in which your oxygen is using its electron to bond with the cobalt is an example of second isomer. Now both of them are placed under linkage isomer because here the ambident ligand is changing its structure. Next is your coordination isomerism. Here what we do, it's very simple. We take two different complexes. So this is also an example of coordination compound where the cationic and anionic part both are played by complex part. Okay, so this is one complex and this is the another complex. Now what we do is we exchange the ligands of these two complexes. So with cobalt we have ammonia and with chromium we have cyanide. But what we can do, we can just put the cyanide along with the cobalt and ammonia with the chromium. So that would give rise to the next type of complex. And these two complexes are coordination isomerism because here the ligands are exchanged between the two complexes of the same coordination compound. Moving on to the next, we have this ionization isomerism. So what is ionization isomerism? Basically here the counter ion which is present outside the coordination sphere, it is being exchanged with the ligand that is present inside the coordination sphere. For example, we can take CONH3 whole 5 SO4 Br. Now what we do? We will simply exchange the Br with the SO4. Okay. So what will happen? As a result of that, we will get two different complexes, but their structures are completely different because the ligands have been exchanged. And since we are exchanging it with the ionizable part, there we call it as ionization isomerism. So it's very simple to remember. Last one, we have this solvate isomerism. What are solvate isomerism? In this case, your complex must contain molecules of water. Okay, and we will exchange the molecules of water as the counterpart. For example, your Cr H2O whole 6 Cl3. So this is your starting complex. Now what are we doing? We are bringing in one Cl inside. Now the coordination number should remain same. Remember, this is very important. So it should be 6, but to keep it equals to 6, we have to bring out one water molecule and keep it as the water molecule which is coordinated through a different manner. You know it, how we have lots of example of the type like CuSO4.5H2O. Similarly, what we have done, we have taken the water and made it a hydrate isomerism. Okay. Similarly, we can put another chlorine inside and take out one more molecule of water outside. So that would give to rise to another type of isomer. Now in all of these three cases, what are we doing? We are changing the hydration number. Here in the first case it is 0. Then we brought one chlorine inside. Therefore the hydration number is 1 because one water molecule is present after dot. In the last case the hydration number is 2. Here we are putting 2 molecules after the dot. But we are bringing the same number of your chlorine inside the coordination sphere. Okay, so this is an example of solvate isomerism. So this was all about the theory part. Next, we will move on to the question. So just wait for a while. Meanwhile, if you have a question regarding the same, you can just post it in the comment section. So this is your first question. The question asks, how many moles of silver chloride will be precipitated when excess silver nitrate AgNO3 is added to 100 ml of a 0.024 molar solution of dichlorobis ethylene diamine cobalt 3 chloride. you need to find the number of moles of AgCl formed based on the given options. First one 0.0012, second one 0.0016, third one 0.0024, and the fourth one 0.0048. Now, an important part is here that you must know how to write the given structure using the given name. As I said it in the start, that you won't be asked a question directly regarding the nomenclature, but a part of it can be used as well. Okay, so both can be the case. So first try to write the given compound, which is dichlorobis ethylene diamine cobalt 3 chloride. So here the central metal ion is cobalt with a +3 oxidation state. Then it is very clear that your complex is cationic in nature because it is named first before the counter ion. So chloride will be present outside it. Then we have 2 molecules of chlorine present inside. It is written here dichloro, right? Next we have bis ethylene diamine, means ethylene diamine, which is your EN. It is present in a count of 2. So we will write the structure first of all, and then it is given that we are adding excess of AgNO3. Remember, your AgNO3 will react with the ionizable chloride to form what? AgCl, and that is the part which will be precipitated. Okay. So according to the question, what are we doing? We are adding excess of AgNO3 here, and we are adding it to a 100 ml solution of 0.024 molar solution. Now first we will find the number of moles here, and then we will try to see that how many number of moles of chloride ion is present. Then accordingly the AgCl will be formed. So the number of chloride ion is equals to the number of the AgCl. So that much will be precipitated by the AgNO3. So if you do that, the correct answer would be 0.0024, which is option number C. So a solution of 100 ml with a concentration of 0.024 molar solution will contain 0.0024 moles of complex. It's very simple. You will multiply both of them and it will give you the corresponding count. Remember to convert this milliliter into liter, because molarity is something which is for liter. Then only we will get the number of moles. Next, how it is calculated, as I said, multiply the volume in liters by molarity, which is your 0.1 liter times 0.024 mole per liter, which will give you 0.0024. This shows that how we can find the amount of substance in the given amount of particular solution. Next, the complex COEN whole twice Cl2Cl contains 1 chloride ion outside. The coordination is fair. Okay, so this is the formula that we will get upon writing the corresponding name. Now it indicates that for every 1 mole of the given compound complex, we will get 1 mole of the chloride ion. So when this solution is treated with the silver nitrate ion, the free chloride ion will react with AgNO3 to form the precipitate AgCl, and this helps us to determine the stoichiometry of the complex. Next, we know that the number of moles of the complex is 0.0024. Therefore, for each mole of the complex there will be 1 chloride ion, and hence we will get 0.0024 moles of chloride ion from the given complex, and that will be the part that will be reacting with the AgNO3 to form the AgCl. Okay. Now the equivalence of the chloride ion and the AgNO3 is same. So therefore, the number of moles of chloride ion present and the number of moles of AgCl formed will be same. Hence, 0.0024 moles of AgCl will be precipitated. Got it? Next question. The question gives 4 platinum complexes with different number of chloride and ammonia ligands. It asks us about their electrical conductance in aqueous solution. Now you have to match these complexes with its corresponding conductance value from the given option. Here the task is to identify the conductance value corresponding to each complex based on the number of ion. So the one which is having a greater number of ion will show a greater conductance. Okay. And the options are given here. You have to look upon the number of ions. First of all, you will try to write each of the complex in their present or good form. Means you have to designate that what are the counter ions and what are the ions that are present inside. Okay. Now, if you do that, you will find that your answer is A, 256, 0, 97, 404. It's very simple. So as I said earlier, when a substance is dissolved in water, it may break into ions. The more ion it produces, the better it conducts electricity. This is because ions are charged particles that can move freely in a solution, allowing electric current to flow. Therefore, solutions with a higher number of ions have higher conductance. For example, sodium chloride produces 2 ions per molecule, making it a good conductor, while a substance that does not dissociate into ions like sugar does not conduct electricity. So first equation shows the dissociation of potassium hexachloroplatinate into its ion in the solution. When dissolved in water, it breaks down into 2 potassium ions and 1 hexachloroplatinate ion, resulting in a total of 3 ions. This indicates that the compound is an electrolyte capable of conducting electricity when dissolved. The dissociation process is irreversible, meaning the ions can combine to form the original compound as well. Now, the second reaction shows the equilibrium between a complex ion and its ion in the solution. In the reaction, PtCl4 2NH3 is in equilibrium with PtNH3 2Cl4. Okay. So, the platinum 4 forms a coordination complex with 2 ammonia molecule and 4 chloride ion. Now, the complex is stable and does not dissociate into free ion, making it as the least ionized molecule. This indicates that the complex is very highly stable and it will not conduct electricity at all. Our next part is the third equation, which shows the dissociation of PtNH3 whole thrice Cl3. Here it will dissociate into 2 parts, where one is chloride ion and other is the complex part including PtNH3 whole thrice Cl3. Now in this question, in this compound, we can clearly see that 2 ions are present, which is greater than the second one and less than the first one. So its conductivity will be in between both of them. Okay, so from that perspective, the 97 value is well good enough. Last one is the dissociation of PtNH3 whole 5 Cl Cl3 into PtNH3 whole 5 Cl3 plus and 3 Cl minus. So it has the maximum number of ions, which is 4. Therefore, it will have the maximum conductance, and hence the A option is correctly validating the given compounds of the platinum. Okay. Very simple. What you have to do is to simply look upon the number of ion it is giving. Upon what? Upon dissociation. Remember, the coordination number in each of them is 6. You consider the first one or the second one, or third one or the fourth one. Now, here is the next question. A solution containing 2.675 grams of COCl3.6NH3, whose molar mass is 267.5 gram mole inverse, is passed through a cation exchanger. So the species that can exchange its cation with the other. It's very simple. As simple as the word is written, cation exchanger. The chloride ions obtained in solution were treated with the excess of AgNO3 to give 4.78 grams of AgCl. Molar mass equals to 143.5 gram mole inverse. The formula of the complexes. Here we have the atomic number of your silver, which is 108U, and the 4 options are given here. Now, the correct answer will be A. So formula would be CONH3 whole 6 Cl3. How we'll solve it? So first of all, we'll find the number of moles of COCl3.6NH3. It's very simple. The calculation shows us how to find the number of moles in a sample of cobalt 3 chloride hexaamine complex. The mass of the sample is 2.675 grams and your molar mass is given as 267.5 grams. You will divide both of them, you will get it as 0.01 mole. Now, here's the chemical equation which shows the precipitation of AgCl upon reaction of AgNO3 with the chloride ion, which is a white precipitate formed into the solution. So, what is the number of AgCl? So, the next thing is to calculate that thing. How we'll do it? It's very simple. So, we know that 4.78 grams of AgCl has been obtained. And what will be the molar mass of AgCl? This thing is also given. It is 143.5. Divide this thing, you will get it as 0.03 mole of AgCl. Now, from the given part, we can say that 0.03 mole of COCl3.6NH3 gives us 0.03 moles of AgCl. This indicates that the remaining Cl negative are inside the complex and do not participate in the reaction. And this also just suggests that the complex has a coordination number of 6 with 6 ammonia and 1 chloride ion outside the sphere. Okay. Now, when a molecule of COCl3.6NH3 dissolves in water, it forms a complex ion. In this case, the cobalt 3 ion is surrounded by 6 ammonia molecule, making it a coordination complex. Only 3 chloride ion is released into the solution, indicating that the complex is stable and only 3 of the 3 chloride ions are ionizable. This shows a complex in tertiary complex with 3 chloride ion outside. The coordination is fair. Okay. Therefore, the formula of the compound will be CONH3 whole 6Cl3. So this is an ionic compound with cobalt in the +3 oxidation state and 3 chloride ion present outside the coordination sphere. Okay. Now, next question number 4. So COCl3.6H2O reacts with excess of AgNO3, and in this 1.2 1.2 into 10 to the power 22 ions are precipitated. Here you have to calculate first of all that what the complex is. For that you have to calculate the number of ions. So options are given here. The correct answer would be D, COH2O whole 5Cl Cl2 dot H2O. How we will do it? It's very simple. First of all, we know that the molarity is the measure of number of moles of solute present in per liter of solution. Now next, to calculate the number of moles of a complex, you use the formula moles is equals to molarity into volume. Since it is given milliliter, we have to divide by 1000. So this formula converts the volume from milliliter to liter by dividing it by 1000 and then multiplies it with the molarity to calculate the total moles of the complex. If you put the values here, you will get it as 0.1 into 100 by 1000. So the total number of moles of complex is 0.01 mole. What is our next target? We can see that the number of moles of ion that precipitate is calculated by the number of ions 1.2 into 10 to the power 22 by Avogadro number, which gives us 0.02 moles. This shows us how many moles of ions have come out of the solution to form a solid precipitate. So this step helps to determine the amount of reaction that has occurred. Now, continuing with the solution, the number of Cl negative present in ionization sphere is equal to ratio of moles of ion precipitated to moles of complex formed. In this case, 0.02 moles of ion were precipitated and 0.01 moles of complex were formed. Dividing this gives us a ratio of 2. This means that for every mole of complex formed, 2 moles of ions were precipitated. This ratio helps determine the stoichiometry of the reaction and the charge of the complex ion. It is a key concept in understanding how ions interact with and form precipitate in the solution. Now, then we get that the 2 chloride ions are located outside the square bracket, meaning they are not a part of the central complex or coordination sphere. Instead, they are in the ionization sphere, which refers to the surrounding ions that are loosely associated with the central metal ion in the solution. Hence, we get this compound COH2O whole 5Cl Cl2 dot H2O, which is a coordination complex of cobalt 3. It contains a cobalt ion surrounded by 5 water molecules and 1 chloride ion in the inner coordination sphere, whereas 2 additional chloride ions are outside, making it a trichloride complex. Okay. The formula also shows that one water molecule is associated as a hydrate since it is written as .2H2O. It is an example of hexa-coordinate cobalt 3 complex with different ligand in the inner and outer sphere. Next, question number 5. The question asks us about the oxidation number and the oxidation state of element E in the complex, whose formula is En whole twice C2O4NO2. You are given a complex and told that En is ethylene diamine. Now you need to find two things. First, how many ligands are attached to E, which is your coordination number, and the charge of E in the complex. Options are A 6 and 2, B 4 and 2, C 4 and 3, and D 6 and 3. The correct answer would be 6 and 3. How will do it? First of all, you have to identify your ligands properly. Your ethylene diamine is a bidentate ligand, and same can be said about the oxalato ion, which can chelate through 2 oxygens. Therefore, the total coordination number would be 6. 4 coming from ethylene diamine and 2 coming from oxalate ion. what is our next target? To calculate the coordination number, sorry, oxidation number. For that, we will try to dissociate our ion. So it will be dissociated as EN whole twice C2O4 with a positive sign and NO2 with a negative sign. Now, what will be the oxidation number? So we will assume that the oxidation number of the metal ion E is X. Ethylene diamine is neutral in nature, so it will have a zero oxidation state. C2O4 is having two negative charge, each for one oxygen. And overall, it is having a positive charge, so we will write it as 1. Now, next, if you just rearrange it, you will get it as X is equals to 3, which is your final answer. Here is your next question. The question asks for the oxidation state for chromium in 3 given compounds. You are given 3 compounds, CrH2O whole 6 Cl3, CrC6H6 whole twice, and K2CrCN whole twice O2, then O2. So one O2 is present as a molecule and the second one is present as a oxide, which has 2 count. You have to calculate the oxidation number of chromium in all of these 3 cases. Options are given here. A +3 +4 and +6, B +3 +2 and +4, C +3 0 and +6, and lastly D +3 0 and +4. So the correct answer would be D +3 0 and +4. How we'll do it? Suppose that the oxidation number of chromium in all these cases are X. Firstly, we will calculate it for CrH2O whole 6 Cl3. So if we take it as X, then for H2O it will be 0 because H2O is neutral in nature. Now next we have chlorine present. Overall this molecule is neutral, so we will take equals to 0. For chlorine we will take it as -1, so 3 multiplied by -1. Then we will just arrange it. It's very simple. You will get it as +3, means the oxidation number of chromium is +3 here. Our next is CrC6H6 whole twice. Now in this case, this C6H6 you are saying is your benzene. Okay. And this benzene, you know it very well, it's neutral in nature. Therefore, X plus 2 into 0 is equals to 0 because overall the complex is having a 0 charge in it. Means it's a neutral complex. Now it's very simple. Your charge on chromium will be 0 from this situation. Lastly, we have to calculate it for K2CrCN whole twice O2 O2 NH3. So this one is a complex one. First of all, for the ligand CN it will be -1, the charge will be -1. Oxygen, it is having a valency of 2 since it is not present in combined state, so each of will have a 2 oxidation state. So that will give you a total of what? Total of 4 negative. What about O2? So O2 is your peroxide. Okay, O2 2 negative. Again here, since one O2 is present, means one peroxide is present with 2 negative charge, therefore charge from this is 2 negative. What about ammonia? It's very simple. It is neutral in nature. And then lastly, we have potassium of count 2, each donating +1 charge. Now, if this is clear, we can simply calculate the value of X from here as +2 plus X minus 2 minus 4 minus 2 is equals to 0. That will give you X minus 6 is equals to 0 or X is equals to 6. Okay. Moving on to the next question. So here you have to find the IUPAC name of the complex PTNH3 whole twice Cl NO2. Options are A, platinum, diamine, chloronitrate. B is chloronitrito and amine, platinum 2. Third one, diamine, chlorido, nitrito and platinum. And option number D, diamine, chloronitrito and platinate. Now, every time you are seeing a N, it represents that your nitrito is connected through the nitrogen. Okay, so this is the significance of writing N. Got it? So, in case of ambident ligand, where 2 possibilities are there, you just specify that which atom of your given ligand is coordinating. So, here nitrogen is coordinating. Next, you have to tell that out of these 4 names, which is the correct IUPAC name. So what we will start with is the cationic part. But in this case, we have a simple complex where there is no charge on it. Okay. But it is a neutral complex. Remember, in the case of neutral complex, we use the term 8. Okay. ATE. Now from this only, we can clearly say that the correct answer is D without any continuation further. Okay. We don't need to further justify it. But for still for your verification, we can just justify your answer. So first of all, we will write the names of the ligands. So we have amine, we have chloride, we have nitrito. Now your nitrite and your chloride both are you are your anionic ligand. So we'll put a O at the last. So it will become nitrito and chlorido. Then we have this NH3, which is represented as amine, but its count is 2. So we'll write it as diamine. Now what is the alphabetic order? So of course amine will come first because it has A in the start. Then will your chlorine will come next because it has C in the start, and lastly will be nitrito N. So it will be diamine, chlorido, or you can write as chloro, then nitrito and platinate. Okay, which is your option number D. Okay, now moving on to the next question. So question is asking you to identify the compound of the given options whose name will be dibromido, bis, ethylene diamine, chromium 3 bromide. So we'll try to define it one by one. First of all, we have dibromido, means two bromines that are present within the complex. Remember, it is not present outside the complex. Why? Because it is written along with the name of your metal ion. Got it? So in all of these, we have two such options where two bromines are present inside. So that from that it is very clear that either option B or option D will be correct. Next is bis ethylene diamine, meaning that two En are present here. Bis means 2. Now in these two examples, of course, your B option is the one which contains 2 ethylene diamine. So from that perspective, your correct answer would be B. So let us verify it further. Then we have chromium in the +3 oxidation state. How can we verify it? It's very simple. So overall the complex should have a 0 charge. Since 3 bromine atoms are present here, to counter that 3 bromine atoms, each having a negative charge, we should have 3 positive charge on the chromium. Means the oxidation state should be +3 for the chromium. Okay. So from this also your correct answer is B. Moving on to the next, we have bromide at the last, which indicates that the counter ion is bromine. Again, that is true for the option number B. Therefore, your correct answer would be option number B. So let me just elaborate it more. So in this coordination complex, there are 2 bromide ion, 2 ethylene diamine molecules, and 1 chromium ion. The chromium is the central metal atom, and it is surrounded by the ligands. The 2 Br negative ions are monodentate, while the 2 En molecule are bidentate ligand. Together, they form a stable complex with the total number of donor atoms equaling the coordination number. After that, the change of one bromine is -1, so 2 bromine has a charge equals to -2. Therefore, the charge of one En is 0, so 2 En has a charge also equals to 0. After that, the charge on chromium central atom is +3, and then the complex becomes CrEn whole twice Br2 positive. Now, the anionic part must have a charge of -1, so that makes it very clear that one bromine atom will be present at the last. Therefore, the overall name of the compound would be CrEn whole twice Br2 Br. So this was all for today's lecture. Thank you for joining the session.
Hello students, how are you all? Welcome to this lecture, one 40 days crash course for JEE. Today is day 25. In this lecture, we will discuss practice questions 1, trigonometric functions and equations. Okay, this is our disclaimer. First, see which topic, what we will cover in this lecture. Okay, so first of all, we will discuss summary. So, whatever we have discussed in our previous lecture, one trigonometric functions and equation, that first we will discuss. Okay, and after that we will solve some practice questions on this chapter. So are you ready to start? So I hope you are well ready. Okay, and you are with your notebooks and pens. So let's get started. So first, see here, angle on circular system. Okay, so we have discussed angle on circular system. So if the angle subtended by an arc of length L at the center of a circle of radius r is theta. Okay, then theta, this is equal to L by r, that you all know. Then we have studied some trigonometric functions like sin theta, cos theta, tan theta, sec theta, cosec theta, okay, cot theta, etc. So trigonometric functions are mathematical functions that related to the angles of triangles and the unit circle. Okay, and here are the basic trigonometric functions typically defined for an angle theta. They are basically sin theta, cos theta, tan theta, cosec theta, tan sec theta, and cot theta. Okay, so these are some basic trigonometric functions that you all know. Then we will see trigonometric identities. So you all know these three trigonometric identities. First identity is sin square theta plus cos square theta equal to 1. Second one is sec square theta minus tan square theta equal to 1. And third one is cosec square theta minus cot square theta equal to 1. Okay, so these three identities are trigonometric identities. These are very useful and important identities. Okay, so many times when we solve problems in this chapter, then frequently we use these three identities. Okay, then we have also studied trigonometric ratios of functions of acute angles. So the ratios of the series of the sides of a triangles with respect to the acute angles are called trigonometric ratios or T series. Okay, so you all know sin theta is equal to, what is this, perpendicular divided by hypotenuse. Okay, similarly you can define cos theta, tan theta, sec theta, cosec theta, cot theta. Okay, understand? Then here we have studied trigonometric ratios of compound angles, like sine of a plus minus b. This is equal to sine a into cos b plus minus cos a into sine b. So if you have sine of a plus b, then this is equal to sine a into cos b plus cos a into sine b. If you have sine of a minus b, then this is equal to sine a into cos b minus cos a into sine b. Clear? Then see, for cosine function, cos of a plus minus b, this is equal to cos a into cos b minus plus sine a into sine b. Okay, when you have cos of a plus b, then this is equal to cos a into cos b minus sine a into sine b. When you have cos of a minus b, then this is equal to cos a into cos b plus sine a into sine b. When you have here plus, then you will get here minus sign. When you have negative sign, then you will get here negative sign, a positive sign. Okay, reverse. Then see, tan of a plus minus b, this is equal to tan a plus minus tan b divided by 1 minus plus tan a into tan b. Okay, so when you have tan of a plus b, then the formula is tan a plus tan b divided by 1 minus tan a into tan b. When you have the tan of a minus b, then this is equal to tan a minus tan b divided by 1 plus tan A into tan B. Okay, clear? Then cot of A plus minus B is equal to cot A into cot B minus plus 1 divided by cot A plus minus cot B. Okay, when you have cot A plus B, then this is equal to cot A into cot B minus 1 divided by cot A plus cot B. When you have cot of A minus B, then this is equal to cot A into cot B plus 1 divided by cot A minus cot B. Understand? Then 1 plus minus tan A divided by 1 minus plus tan A. This is equal to tan of pi by 4 plus minus A. When you take plus, okay, then 1 plus tan A divided by 1 minus tan A, this is equal to tan of pi by 4 plus A. When you have 1 minus tan A divided by 1 plus tan A, this is equal to tan of pi by 4 minus A. Okay. Then we have studied some trigonometric ratios of multiple angles, like sin 2a, sin 2 equal to 2 sin a into cos a, and this is equal to 2 tan a divided by 1 plus tan square a. Then cos 2a, this is equal to cos square a minus sin square a. This is equal to 1 minus tan square a divided by 1 plus tan square a. Okay, and here cos 2a is also equal to 2 cos square a minus 1. Okay, and this is equal to also 1 minus 2 sin square a. So these are some important formulas, one trigonometric functions, okay, one trigonometric ratios of compound angles and trigonometric ratios of multiple angles. So you should keep in your mind this formula. Okay, these formulae are very useful and important formula in the point of view of exam. Okay, then see another identities like conditional identities. Okay, so if you sum of angles A plus B plus C equal to 180 degrees, then you will get some conditional identities like sin 2A plus sin 2B plus sin 2C. This is equal to 4 times sin A into sin B into sin C. So cos 2A plus cos 2B plus cos 2C. This is equal to minus 1 minus 4 times cos A into cos B into cos C. Then tan A plus tan B plus tan C equal to tan A into tan B into tan C. Then maximum and minimum values of the function, trigonometric function. So maximum value of a cos theta plus minus b sin theta is square root of a square plus b square, and minimum value of a cos theta plus minus b sin theta is equal to minus of square root of a square plus b square. Then maximum value of a cos theta plus minus b sin theta plus c is equal to c plus square root of a square plus b square. Then minimum value of a cos theta plus minus b sin theta plus c equal to c minus square root of a square plus b square. Okay, so note these formula, these are very useful formula. Okay, then trigonometric equations. So an equation involving one or more trigonometrical ratios of unknown angle, this equation is called a trigonometric equation. Then what is principal solution? So the value of the unknown angle theta which satisfies the trigonometric equation is known as principal solution. Here you have to note also, here theta is greater than equal to 0 and less than 2 pi. Then general solution. So the solution consisting all possible solution of a trigonometric equation is called its general solution. Then we have studied some summation of some trigonometric race series. Okay, so like sin alpha plus sin of alpha plus beta plus sin of alpha plus 2 beta plus dot 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 to n terms. So this is equal to sin of n beta divided by 2 divided by sin of beta by 2 times sin of alpha plus n minus 1 times beta by 2. Okay, so note this point and you should keep in your mind. Then cos alpha plus cos of alpha plus beta plus cos of alpha plus 2 beta plus dot 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 to n terms, this is equal to sin of n beta by 2 divided by sin of beta by 2 times cos of alpha plus n minus 1 times beta by 2. Okay, so here we have revised our concept that we have studied in our previous lecture. Okay, so now we will start some practice questions, one trigonometric functions and equation. So see here, first question. In this question, you have sine theta, this is equal to minus 4 by 5. And here theta lies in the third quadrant. Okay. And then what is cos of theta by 2? That means here we have to find the value of cos of theta by 2. Okay. And you have given 4 options. Among these 4 options, which option is correct, that you have to find. Okay. So first of all, try it yourself first. Okay. And give your answer in chat section. Everyone, write your answer in chat section. Okay. Try it. Take your time and try it. Very simple question. It will take hardly 1 minute. Okay. So do it, everyone, and give your answer. Everyone, give your answer. Which option is correct here? Very simple question. You can do it. Everyone, do it and give your answer. Okay. So write your answer in chat section. Which option is correct? Here focus 1. Here theta lies in the third quadrant. Okay. And then try to understand where theta by 2 will be lie. Okay. And by using sine theta equal to minus 4 by 5, find the value of cos of theta by 2. So everyone, give your answer in chat section. Write your answer in chat section. Which option is correct here? Are you doing? Are you trying to solve? Which option is correct? Very simple. Okay. I hope you try to solve this. Okay. And you got your answer. So now let's check which option is correct. The correct answer is option B. So first of all, match with your answer. Then which formulas here we will use? Here first we will use sin square x plus cos square x equal to 1, this formula. Okay. And we will also use here cos theta equal to 2 cos square theta by 2 minus 1. Okay. This one also. Then let's solve this question. So what we have given here? We have given that sin theta is equal to minus 4 by 5. And here theta lies in the third quadrant. Okay. Now what we have to do? We have to find cos of theta by 2. Okay. So here you all know cos theta, this is equal to square root of 1 minus sin square theta. Okay. So using this formula, you will get cos theta equal to square root of 1 minus sin square theta. This is equal to square root of 1 minus 16 by 25. Okay. And here we take minus. Okay. Why? Because here theta lies in the third quadrant. Okay. So here take we minus square root of 1 minus 16 by 25. This is equal to minus of 3 by 5. Now we have to find cos of theta by 2. Okay. And you know well the formula cos theta, this is equal to 2 cos square theta by 2 minus 1. From this formula, you can write cos of theta in terms of cos theta. Okay. You will get cos of theta by 2, this is equal to plus and minus square root of 1 plus cos theta divided by 2. Okay. So cos of theta by 2, this is equal to plus minus square root of 1 plus cos theta divided by 2. And now here put the value of cos theta equal to minus 3 by 5. Okay. Then you will get this is equal to plus or minus square root of 1 minus 3 by 5 divided by 2. This is equal to plus minus square root of 1 by 5. Okay. Now let's check here which value we will take for the cos of theta by 2. Okay. Here but we take here cos of theta by 2, this is equal to minus 1 by root 5. Why? Because here theta lies in the third quadrant. Okay. Theta lies in the third quadrant. So theta by 2, that will be lie in the second quadrant. Okay. And in second quadrant, cosine function is negative. Okay. So cos of theta by 2, this is equal to minus 1 by root 5. Hence, we will get cos of theta by 2, this is equal to minus 1 by root 5. Okay. Therefore, the value of cos of theta by 2, this is equal to minus 1 by root 5, and this is our final answer. So I hope you will understand. Okay, and it's clear to all of you. Now moving to the next question. In this question, we have given the expression tan A divided by 1 minus cot A plus cot A divided by 1 minus tan A. Okay, and we have to write this expression into the simplest form. Okay, and here we have given some answer, okay, in 4 options. So we have to find which option is correct here. So first of all, try it one year one, okay, and write your answer in chat section. Everyone do it. Try it. Everyone try it and write your answer in chat section. Everyone. Everyone do it. Take 1 minute and try to solve this question. Everyone. Which option is correct here? Please write your answer. Let's try it and give your answer. Which option is correct? Everyone try it and give your answer. Easy question. You can do it. Okay, just you have to simplify the given expression. Okay, everyone do it. Everyone do it and write your answer in chat section. Do it. Which option is correct here? Are you trying to do it? Are you trying? Please write your answer in chat section. Which option is correct here? Everyone do it and write your answer in chat section. Very simple question. You can do it. I hope you got your answer. Okay. So now let's check which option is correct here. The correct answer is option B. So now let's see which concept or formula we use here, okay, and how to solve this. Here we use the formula tan x equal to sin x by cos x, cot x is equal to cos x by sin x, sin square x plus cos square x equal to 1, and 1 by sin a into cos a, this is equal to cosec a into sec a, okay, sec of a. So we use this formula to solve the given question. Okay, so now let's solve this question step by step. So given expression is tan a divided by 1 minus cot a plus cot a divided by 1 minus tan a. Okay, and if you use here this formula tan x equal to sin x by cos x, then you can write tan a as sin a by cos a. Okay, and you can write cot a as cos a divided by sin a, and then you will get sin a by cos a times sin a divided by sin a minus cos a. Okay, then plus here you can write cot a as cos a by sin a, then you can write tan a as sin a by cos a, then if you simplify then you will get cos a by cos a minus sin a. Okay, now let's simplify further. So this is now if we common out sin a minus cos a, okay, so you will get 1 by sin a minus cos a, and in denominator you will get sin a minus cos a. Okay, so 1 by sin a minus cos a times here sin cube a minus cos cube a divided by cos a into sin a. Okay, so if you carefully see this expression and if you simplify, then you will get 1 by sin A minus cos A times sin cube A minus cos cube A divided by cos A into sin A. Understand? Now, if we further simplify, okay, and now you can write this expression as sin square A plus sin A into cos A plus cos square A. Okay, how? You can use the formulas A cube minus B cube formula. Okay, you all know A cube minus B cube, this is equal to A minus B times A square plus AB plus B square. Okay, so if you use this formula, then you can write sin cube A minus cos cube A as sin A minus cos A times sin square A plus sin A into cos A plus cos square A. Okay, so now if you see here numerator and denominator, then you will can see here sin A minus cos A is common to in numerator and denominator, they will cancel to each other, and then you will get sin square A plus sin A into cos A plus cos square A divided by sin A into cos A. Okay, clear? Then if we further simplify here, if we use now sin square A plus cos square A is equal to 1, then this is equal to 1 plus sin A into cos A divided by sin A into cos A. Clear? And this is equal to 1 plus sec A into cos A. Why? Because if we simplify further, then you can write 1 by sin A into cos A plus sin A into cos A by sin A into sin A, sin A into cos A. Okay, that will cancel to each other, and you will get 1. So 1 plus 1 by sin A into cos A, and here 1 by sin A into cos A is cosec A into sec A. Okay, so this is equal to 1 plus sec of A into cosec of A. Clear? And this is our final answer. So I hope you will understand. This is very simple, easily we have done. Okay, and just we simplify using some importance formula of trigonometric functions. Okay, and I hope it's clear to all of you, and if you have any doubt, then you can ask. Okay, do you have any doubt in the solution? Very simple question. I hope you have no doubt. Okay, now moving to the next question. In this question, if tan theta, 2 tan theta plus 2 and 3 tan theta plus 3, these three numbers are in GP, that means these three numbers are in geometric progression. Okay, then we have to find the value of 7 minus 5 cot theta divided by 9 minus 4 times square root of sec square theta minus 1. Okay, so here we have given 4 options. You have to choose the correct answer from the given options. So first of all, try it yourself first. Okay, and write your answer in chat section. So everyone try it and give your answer. Everyone take your time and write your answer in chat section. Everyone do it. Everyone do it. Very simple question. Easily you can do it. Very simple question. Just you have to use the concept of geometric progression. Okay, so when you have 3 terms in geometric progression, then what concept you can use? Okay, think about that and try to find the value of cot theta. Okay, and then simplify the expression 7 minus 5 cot theta divided by 1 minus 4 times square root of sec square theta minus 1. So everyone do it and write your answer in chat section. Which option is correct? Everyone give your answer. Please write your answer in chat section. Which option is correct? Very simple question. You can easily do it. Everyone do it. And write your answer in chat section. Very simple question. So if A, B and C, 3 numbers are in GP, then what can you say? We can write B square is equal to AC. Okay, B square is equal to A times C. So use this concept and try to find the value of tan theta. Okay, if you get the value of tan theta, then you easily can find the value of cot theta, and by using sec square theta minus tan square theta equal to 1, you can find sec square theta minus 1, that value. Okay, so everyone give your answer. Which option is correct? Very simple question. Do it and write your answer. Everyone do it and write your answer in chat section. Everyone do it and write your answer. Are you trying to do it? Are you trying to do it? Everyone, are you trying to do it? Okay. Now we will check which option is correct. The correct answer is option C. Okay. Now see which formula and key point used here. So if A, B, C are in GP, then B squared equal to A times C. Okay, and here B is called geometric progression, geometric mean of A and C. Okay, and you all know sec square theta minus 1 is equal to tan square theta. Okay, and now let's solve this question step by step. So we have here tan theta, 2 tan theta plus 2 and 3 tan theta plus 3 are in GP. Okay, so you can write 2 tan theta plus 2 whole squared. This is equal to tan theta times 3 tan theta plus 3. Okay, that means you can write the middle term in terms of multiplication of first and third term. Okay, so 2 tan theta plus 2 whole squared, this is equal to tan theta times 3 tan theta plus 3. Understand? Do you understand? Now let's simplify. So it implies 4 tan square theta plus 8 tan theta plus 4. This is equal to 3 tan square theta plus 3 tan theta. Okay. Now let's simplify further. So it implies tan square theta plus 5 tan theta plus 4. This is equal to 0. Okay. Now let's solve this quadratic equation. So you can factorize and you can solve. So you can factorize this quadratic equation as tan theta plus 4 times tan theta plus 1 is equal to 0. Okay. From here you will get tan theta is minus 4 or tan theta is minus 1. Okay. So which value of tan theta will take here? Which value of tan theta will take here? Here since tan theta is not equal to minus 1. Okay. Why? Because if you take tan theta is minus 1, then you will get the three terms as minus 1, then minus 2 plus 2, that is 0. Okay, and minus 3 plus 3 is 0. Okay, so then these three numbers are not in GP. Okay, so that's why here we will not tan theta is not equal to minus 1. Okay, we will not take minus 1 as the value of tan theta. Here we will take tan theta is equal to minus 4. Tan theta is equal to minus 4. Now, using this value, we can simplify the expression 7 minus 5 cot theta divided by 9 minus 4 times square root of sec square theta minus 1. Okay. So, tan theta is minus 4. So, what will be the value of cot theta? So, cot theta is reciprocal of tan theta. Okay, reciprocal of tan theta. So, cot theta is equal to minus 1 by 4. Okay, cot theta is equal to minus 1 by 4. And you will know sec square theta minus 1 is equal to tan square theta. Okay, so you can write sec square theta minus 1 as tan square theta. So you can write this is as 7 minus 5 cot theta divided by 9 minus 4 times square root of tan square theta. Okay, now substitute the values of cot theta is equal to minus 1 by 4 and tan theta is equal to minus 4. Then you will get this expression as 7 plus 5 by 4 divided by 9 minus of minus 4 times minus 4. Okay, so this is equal to 33 by 100. This is equal to 33 by 100, and this is our final answer. Clear? So the value of 7 minus 5 cot theta divided by 9 minus 4 times square root of sec square theta minus 1 is equal to 33 divided by 100. Clear? Is it clear to all of you? Do you have any doubt? If you have any doubt in the solution, then you can freely ask. Okay, so everyone, if it's clear, then write in chat section CLR. Okay, otherwise you can ask your doubt. Do you have any doubt in any step? In any step you have doubt? Do you have doubt any? Very simple. Okay, and here we have done every step. Okay, we have do uh, every step of this solution, and it's clear to all of you. Now moving to the next question. In this question, here we have sine of alpha plus beta equal to 1 and sine of alpha minus beta equal to 1 by 2. Okay, then tan of alpha plus 2 beta times tan of 2 alpha plus beta is equal to what? You have given here 4 options. Okay, and you have to choose the correct answer from the given options. So everyone, try to solve this question first. Okay, and write your answer in chat section. So take your time and write your answer in chat section. Everyone do it and write your answer. Which option is the correct answer here? Very simple question. You can do it. Everyone do it. Very simple question. You can do it. Everyone, try it and write your answer. Do it first. Are you trying? Try it and give your answer. Try it and give your answer. Everyone, try it. Try it. Everyone, try it. Very simple question. You can do it. Okay. Now let's check which option is correct. The correct answer is here option A. Okay. Now see which formula and key points used in this question. So you will know tan of pi minus theta is equal to minus tan theta. Okay. And you also know sine inverse of 1 is equal to pi by 2. And sine inverse of 1 by 2 is equal to pi by 6. Okay. Now let's solve this question step by step. Since here we have sine of alpha plus beta equal to 1. Okay. So you can write this equation as alpha plus beta equal to sine inverse of 1, and here the value of sine inverse of 1 equal to pi by 2. So you will get this equation alpha plus beta equal to pi by 2. Okay. So naming this equation number 1. Then you have sine of alpha minus beta is equal to 1 by 2. Okay. And you can write this equation as alpha minus beta is equal to sine inverse of 1 by 2, and you know sine inverse of 1 by 2 is equal to pi by 6. Okay. From here you will get the another equation alpha minus beta equal to pi by 6. Okay. This is equation number 2. Now, once solving equation 1 and 2, here we get alpha is pi by 3 and beta is pi by 6. Okay, everyone you can do. Okay, everyone you can solve equation 1 and 2 by using substitution method or elimination method. Okay, as you wish, you can use substitution method or elimination method. So if you use elimination method here, then you will get the value of alpha is pi by 3 and beta is pi by 6. Clear? So we got here the values of alpha is pi by 3 and beta is pi by 6. Now tan of alpha plus 2 beta times tan of 2 alpha plus beta. Okay, here we have this expression and we have to find the value of the expression tan of alpha plus 2 beta times tan of 2 alpha plus beta. Okay, and here we obtain the values of alpha and beta. Now just we substitute here the values of alpha and beta and then we simplify and then we will get the answer. So here if we substitute the values of alpha and beta, then here you will get tan of 2 pi by 3 times tan of 5 pi by 6. Okay. Now let's find the value of tan of 2 pi by 3 and tan of 5 pi by 6. So you can write tan of 2 pi by 3 as tan of pi minus pi by 3. Okay. And you can write tan of pi by 6 as tan of pi minus pi by 6. And you will know the formula tan of pi minus theta equal to minus tan theta. Okay. So tan of pi minus pi by 3 is equal to minus tan of pi by 3 and tan of pi minus pi by 6 is equal to minus tan of pi by 6. Okay. And the value of tan of pi by 3 is root 3. Okay. And tan of pi by 6 is 1 by root 2, 1 by root 3. So here minus will be plus, minus into minus is plus, and here you get the value of tan pi by 3 is root 3 and tan pi by 6 is 1 by root 3. So you will get root 3 times 1 by root 3. Here root 3 cancelled and you will get this is equal to 1. Okay. So the value of tan of alpha plus 2 beta times tan of 2 alpha plus beta is equal to 1, and this is our final answer. Okay, this is our final answer. So I hope you will understand and it's clear to all of you. Okay, very simple question. Is it clear to all of you? Is it clear to all of you? Is it clear to all of you? Do you have any doubt? No doubt? Very simple. We have done here each step. Okay. So now moving to the next. Here we have the expression sec A plus sec of B plus sec of C. Okay. And here we have to find the least value in an acute angle triangle. Okay, in an acute angle triangle we have to find the least value of sec of A plus sec of B plus sec of C. Here we have given 4 options, so you have to choose the correct answer from the given options. So everyone try it and give your answer in chat section. Okay, so everyone write your answer in chat section. Please try it and write your answer. Everyone, very simple question, you can do it. So you have to focus here. This is we are finding the least value of sec of A plus sec of B plus sec of C in an acute angle triangle. Okay, and you will know acute angle means that angles which is less than 90 degrees. Okay, so everyone do it and give your answer. Everyone do it, everyone try it and write your answer in chat section. Very simple question, you can do it. Are you trying? Are you trying to do it? Try it and write your answer in chat section. Now let's check which option is correct here. The correct answer is option D. Okay. And here the formula and key points. Here we used AM is greater than equal to HM, and here we will use cos theta equal to 1 by sec of theta. Okay. Now let's solve this question step by step. So here sec A, sec of B and sec of C all are positive in an acute angle triangle. Okay. And now also arithmetic mean is always greater than equal to harmonic mean. Now arithmetic mean of sec of A, sec of B and sec of C is basically sec of A plus sec of B plus sec of C divided by 3, and harmonic mean of sec of A, sec of B and sec of C is 3 divided by cos of A plus cos of B plus cos of C. Okay. So here we got this inequality sec A plus sec B plus sec C divided by 3 is greater than equal to 3 divided by cos of A plus cos of B plus cos of C. So we have in triangle ABC cos A plus cos B plus cos C is less than equal to 3 by 2. Okay. So this is always less than equal to 3 by 2. And now you will get 1 by cos A plus cos B plus cos C is greater than equal to 2 by 3. Okay. And now it implies 3 by cos A plus cos B plus cos C is greater than equal to 2. Clear? So from here you will get sec of A plus sec of B plus sec of C divided by 3 is greater than equal to 3 by cos of A plus cos of B plus cos of C is greater than equal to 2. Okay. Therefore, sec of A plus sec of B plus sec of C divided by 3 is greater than equal to 2. So what is the least value of sec A plus sec of B plus sec of C? Therefore, it implies sec of A plus sec of B plus sec of C is greater than equal to 6. Okay. So the least value of sec of A plus sec of B plus sec of C is 6. Understand? So our final answer is 6. So I hope you will understand and it's clear to all of you. Okay. Here sec of A plus sec of B plus sec of C is greater than equal to 6, and from here you get the answer. The least value of sec of A plus sec of B plus sec of C is 6. Understand? It's clear to all of you? I hope it's clear to all of you. Now moving to the next. So before moving to the next, please wait a minute. Okay. Now see this question. Here if sin A plus sin B whole square plus cos A plus cos B whole square, this is equal to 2, and cos A plus minus sin A, this is equal to 1 by root 2, then what is the value of A? You have given here 4 options, so you have to choose the correct answer from the given options. So first of all, try it on your own and write your answer in chat section. So everyone try it and write your answer. Do it. Very simple question. Do it. Everyone do it and write your answer. So let's check which option is correct here. The correct answer is option A. Here we will use the formula cos of A minus B. This is equal to cos A into cos B plus sin A into sin B. Now let's solve this question. Here given sin A plus sin B whole squared plus cos A plus cos B whole squared is equal to 2. Okay. And now expand and here use the Pythagorean identity. Then we get here 2 plus 2 of sin A into sin B plus cos A into cos B. This is equal to 2. Now simplify to cos of B minus A. This is equal to 0. And therefore B is equal to A plus 90 degrees. Why? Because you know cos of 90 degrees equal to 0. So cos of B minus A equal to 0. From here you will get B equal to A plus 90 degrees. Now given here cos A minus sin A, this is equal to 1 by root 2. Now here dividing both sides by 1 by root 2, then we can write it as cos A into cos 45 degree minus sin A into sin 45 degree equal to 1 by 2. Okay. And now using the cosine addition formula, so here cos of A plus 45 degree equal to cos 60 degrees, and hence A equal to 15 degrees. A equal to 15 degrees. The value of A is 15 degrees. So I hope it's clear to all of you and you understand. Okay. So before moving to the next question, please wait a moment. Now see next question. In this question, here in a triangle PQR, angle R is pi by 2, and if tan of P by 2 and tan of Q by 2 are the roots of the equation ax squared plus bx plus c equal to 0, where a is not equal to 0, then here what will be the relation between a, b and c? Here we have given 4 options. So you have to choose the correct answer from the given options. So everyone try it and give your answer. Okay, very simple question. Try it and give your answer. Which option is correct here? Which option is correct here? Very simple question. You can do it. Try it. Everyone try it. Are you trying to do it? So write your answer in chat section. What do you know about the relation of roots and the coefficients? So you will know the sum of roots. If alpha beta be two roots of the quadratic equation x square plus bx plus c equal to 0, then alpha plus beta, this is equal to minus b upon a. Okay, that means this is equal to minus coefficient of x divided by coefficient of x square, and alpha times beta, that means product of alpha and beta, this is equal to c divided by a. Okay, here the c is constant term and a is coefficient of x square. So use this concept and try to build the relation between a, b and c, and write your answer in chat section. Which option is correct here? Everyone do it and write your answer. Very simple question. You can do it. Do it. Everyone try it. Okay. So let's see which option is correct here. The correct answer is option C. Now we will see formula and key points that we will use here. So you know, well, for any quadratic equation ax square plus bx plus c equal to 0, which roots are alpha and beta, the sum of roots alpha plus beta is minus b upon a, and product of roots alpha times beta equal to c upon a, and the sum of the interior angles of a triangle is value is 180 degrees. Okay, so now also use here the formula tan of a plus b equal to tan a plus tan b divided by 1 minus tan a into tan b. Now let's solve this question step by step. Since here tan p by 2 plus tan q by 2, this is equal to minus b upon a. Why? Because tan p by 2 and tan q by 2 are the roots of the equation ax square plus bx plus c equal to 0. Okay, so sum of tan of p by 2 and tan of q by 2, this is equal to minus coefficient of x divided by coefficient of x square. Okay, and product of tan of p by 2 and tan of q by 2, that is tan of p by 2 times tan of q by 2, this is equal to c upon a. Okay, understand? Now also here the interior angle, sum of interior angles of a triangle is 180 degrees. Okay, so if we divide by 2, then p by 2 plus q by 2 plus r by 2, this is equal to pi by 2. And here since you have the angle r is pi by 2. Okay, so then p plus q by 2, this is equal to pi by 4. Now it implies tan of p by 2 plus tan of q by 2 divided by 1 minus tan of p by 2 times tan of q by 2, this is equal to 1. Okay, it implies minus b upon a divided by 1 minus c upon a equal to 1. Here we use tan of p by 2 plus tan of q by 2 equal to minus b upon a, and tan p by 2 times tan q by 2 is equal to c upon a. Okay, and here we got minus b upon a divided by 1 minus c upon a. this is equal to 1. And from this equation you will get the relation of C and A and B. Here C is equal to A plus B. Okay, and this is our final answer. So I hope you will understand and it's clear to all of you. Okay, now moving to the next. In this question, here we have if cos of alpha plus beta equal to 4 by 5 and sine of alpha minus beta this is equal to 5 by 13. Here where 0 less than equal to alpha comma beta less than equal to pi by 4. Then what is tan 2 alpha? Here we have given 4 options. So you have to choose the correct answer from the given options. So first of all, try it on your own. Okay, and write your answer in chat section. So everyone try it. Everyone try it. Do it. Which option is correct here? Which option is correct here? Give answer. Give your answer. Okay, let's see which option is correct here. The correct answer is option B. Okay. Now see which formula and key points used here. So first here we will use tan of A plus B equal to tan A plus tan B divided by 1 minus tan A into tan B, this formula. Okay, so let's solve this question step by step. You have cos of alpha plus beta equal to 4 by 5. Okay, and from here we'll get alpha plus beta is lies in first quadrant. Okay, and sine of alpha minus beta equal to 5 by 13, and it implies alpha minus beta lies in first quadrant. Now as 2 alpha, this is equal to alpha plus beta plus alpha minus beta. Okay, so you can algebraically manipulate 2 alpha as alpha plus beta plus alpha minus beta. And therefore tan 2 alpha this is equal to tan of alpha plus beta plus tan of alpha minus beta divided by 1 minus tan of alpha plus beta times tan of alpha minus beta. Okay, now you can write tan of alpha plus beta as sine alpha plus beta divided by cos alpha plus beta. Okay, and tan alpha minus beta can be written as sine of alpha minus beta divided by sine cos of alpha minus beta. So now put here the values of cos of alpha plus beta equal to 4 over 5. Okay, and sine of alpha minus beta equal to 5 by 13, and similarly you can find cos of alpha minus cos of alpha minus beta value. Okay, and the value of sine of alpha minus beta. Okay, sine of alpha plus beta. Okay, then if we put these values into this formula, then you will get the expression as 3 by 4 plus 5 by 12 divided by 1 minus 3 by 4 times 5 by 12. Okay, now if you simplify further, then you will get this is equal to 56 by 33. Okay, and this is our final answer. So I hope you will understand. Okay, is it clear to all of you? Is it clear to all of you? Do you have any doubt? Very simple. From the value of cos of alpha plus beta equal to 4 by 5, you can find sine of alpha plus beta by using the formula sine square x plus cos square x equal to 1. Okay, and from the value of sine of alpha minus beta equal to 5 by 13, you can find cos of alpha minus beta by using the formula sine square x plus cos square x equal to 1. Okay, and then if we write tan of if we can write tan of alpha plus beta equal to sine of alpha plus beta divided by cos of alpha plus beta, and tan of alpha minus beta equal to sine of alpha minus beta divided by cos of alpha minus beta. Okay, and if we put the values of these, then you will get this is equal to 56 by 33, and this is our final answer. So I hope you will understand. Okay, now moving to the next. In this question, here if sine alpha is equal to x and sine beta is equal to y and sine of alpha plus beta equal to z. Then cos of alpha plus beta as a rational function, okay, as a rational function is what? So we have given four options, so you have to choose the correct answer from the given options. So first of all, try it and give your answer. So everyone try it, and give your answer. Very simple, you can do it. Try it. So now let's check which option is correct. The correct answer is option B. Which formula and key points used here? Here first use the sine of a plus b formula, that is sine a plus sine a into cos b plus cos a into sine b. And then use here the sin square theta plus cos square theta is equal to 1, this formula. And now let's solve this question step by step. So we have x is equal to sin alpha, y is equal to sin beta, and z equal to sin of alpha plus beta. And here z sin of alpha plus beta, you can write sin alpha into cos beta plus cos alpha into sin beta. So z equal to sin alpha into cos beta plus cos alpha into sin beta. Okay, now you can put the values of sin alpha equal to x and sin beta equal to y, and from there you will can find the value of cos alpha and cos beta. Okay, and here you can put the values of sin alpha, cos beta, cos alpha and sin beta. Then z equal to x times cos beta plus y times cos alpha. Okay, you will get this. Sin alpha is x and sin beta is y. So you get z equal to x times cos beta plus y times cos alpha. So now z square, this is equal to x square times cos square beta plus y square times cos square alpha plus 2xy times cos alpha into cos beta. Okay, and now you can write z square, this is equal to x square times 1 minus y square plus y square times 1 minus x square. Why? Because you know sin square theta plus cos square theta is equal to 1. Okay, so using this formula you can write cos square beta as 1 minus sin square beta, and sin beta is y, so 1 minus sin square beta is 1 minus y square. And similarly cos square alpha can be written as 1 minus sin square alpha, and sin alpha is x, so cos square alpha is equal to 1 minus x square. Okay, so z square, this is equal to x square times 1 minus y square plus y square times 1 minus x square plus 2xy times cos alpha times cos beta. Now further if you simplify, then you will get z square, this is equal to x square plus y square minus 2 times x square times y square plus 2xy times cos alpha into cos beta. Okay, and here you will get z square, this is equal to x square plus y square plus 2xy times cos alpha into cos beta minus sin alpha into sin beta. Okay, and you know cos of alpha plus beta, this is equal to cos alpha into cos beta minus sin alpha into sin beta. So you can write cos alpha into cos beta minus sin alpha into sin beta as cos of alpha plus beta. Okay, so z square minus x square minus y square, this is equal to 2 times xy times cos of alpha plus beta. Now cos of alpha plus beta, this is equal to z square minus x square minus y square divided by 2 times xy. Okay, and this is the rational form of cos of alpha plus beta. So cos of alpha plus beta can be written as a rational function as z square minus x square minus y square divided by 2 times xy. Okay, clear? Understand? I hope it's clear to all of you. Okay, and you have no doubt. So now let's move to the next question. In this question, here first we let alpha and beta be such that sin alpha plus sin beta, this is equal to minus 21 divided by 65. Okay, and cos alpha plus cos beta equal to minus 27 by 65. Then you have to find the value of cos of alpha minus beta by 2. Okay, so you have given 4 options, so you have to choose the correct answer from the given options. So first of all, try it and write your answer in chat section. So everyone, try it and give your answer. Try it. Everyone, try it. Which option is correct here? Which option is correct here? Do it. Very simple. You can do it. Are you trying to do it? Are you trying? Which option is correct? Which option? I hope you got your answer. So now let's check which option is correct here. The correct answer is option B. So first of all, match with your answer, whatever you get. Then see which formula and key points used for solving this problem. So first formula, cos of A minus B, this is equal to cos A into cos B plus sin A into sin B. Then sin square theta plus cos square theta is equal to 1. Now let's solve this question step by step. Here given that sin alpha plus sin beta, this is equal to minus 21 divided by 65. Okay, and naming this equation number 1. And cos alpha plus cos beta, this is equal to minus 27 by 65, naming this equation number 2. Okay, and now on squaring and adding equations 1 and 2, then we get here sin square alpha plus sin square beta plus 2 sin alpha cos sin beta plus cos square alpha plus cos square beta plus 2 cos alpha into cos beta. Okay, this is equal to minus 21 by 65 whole square plus minus 27 by 65 whole square. Understand? Clear? Now it implies 2 plus 2 times cos alpha into cos beta plus sin alpha into sin beta. This is equal to 441 by 4225 plus 729 by 4225. And it implies 2 times 1 plus cos of alpha minus beta. This is equal to 1170 divided by 4225. Okay. Further simplify, then you will get cos square alpha minus beta by 2. This is equal to 1170 divided by 4 times 4225. And it implies cos square alpha minus beta by 2. This is equal to 9 by 1 square root of 9 by 130. Okay. And it implies cos of alpha minus beta by 2. This is equal to plus minus 3 by square root of 130. And therefore cos of alpha minus beta by 2, this is equal to minus 3 by square root of 130. Okay. Clear? The value of cos of alpha minus beta by 2, this is equal to minus 3 by square root of 130. And this is our final answer. So I hope you will understand. Okay. So now see this, look at this question. In this question here we have if a plus b plus c equal to pi. Okay, and cos a equal to cos b times cos c, then we have to find tan b into tan c. Okay, here we have given 4 options, so you have to choose the correct answer from the given options. So which option is correct here, that you have to find. So everyone try it and write your answer in chat section. Everyone, do it. Take your time and try to solve this question first of all, and write your answer in chat section. Which option is correct? So let's check which option is correct here. The correct answer is option B. Now we will see which formula and key points used to solve this question. So here first we will use cos of pi minus theta, this is equal to minus cos theta, and cos of a minus b, this is equal to cos a into cos b plus sin a into sin b. Now let's solve this question. Since here we have a plus b plus c equal to pi, okay, and therefore a equal to pi minus of b plus c. Now we have cos a, this is equal to cos b times cos c. So cos of pi minus b plus c, this is equal to cos a into cos c. And now use cos of pi minus theta equal to minus cos theta. Then you can write cos of pi minus of b plus c, this is equal to minus of cos b plus c. This is equal to cos b into cos c. And now use cos of b plus c is equal to cos b into cos c minus sin b into sin c. So you can write the equation as minus of cos b into cos c minus sin b into sin c is equal to cos b into cos c. And for the if you simplify, then it implies sin b into sin c is equal to 2 times cos b into cos c. And it implies tan b times tan c, this is equal to, okay. Therefore, the value of tan b times tan c is equal to 2. So I hope you will understand. It's clear to all of you? Do you have any doubt in any question? Do you have any doubt in any question? If you have any doubt, then you can ask in chat section, okay. I hope you don't have any doubt, okay, and everything is clear to all of you. Now, see here another question. In this question here we have if tan alpha, this is equal to 1 plus 2 to the power minus x to the power minus 1, and tan beta is equal to 1 plus 2 to the power x plus 1 to the power minus 1, then alpha plus beta equals what? Okay, you have given here 4 options, so you have to choose the correct answer from the given options. So everyone try it and give your answer. Which option is correct? Try it and give your answer. Okay, let's see which option is correct. The correct answer is option B. Here we will use tan of a plus b equal to tan a plus tan b divided by 1 minus tan a into tan b, this formula. So now let's solve this question. So we know here tan of alpha plus beta, this is equal to tan alpha plus tan beta divided by 1 minus tan alpha into tan beta. Since here tan alpha is 1 by 1 plus 2 to the power minus x and tan beta is equal to 1 by 1 plus 2 to the power x plus 1, okay, these are given to us. And therefore tan of alpha plus beta, this is equal to 1 by 1 plus 1 by 2 to the power x plus 1 by 1 plus 2 to the power x plus 1 divided by 1 minus 1 by 1 plus 1 by 2 to the power x times 1 by 1 plus 2 to the power x plus 1. Okay, let's simplify. So it implies tan of alpha plus beta, this is equal to 2 to the power x plus 2 times 2 to the power 2x plus 2 to the power x plus 1 divided by 1 plus 2 to the power x plus 2 times 2 to the power x plus 2 times 2 to the power 2x minus 2 to the power x. Okay, and here you can simplify further. Okay, here 2 to the power x and minus 2 will be cancelled. Okay, and here numerator and denominator will be same, so they will cancel to each other. Then tan of alpha plus beta, this is equal to 1, and it implies alpha plus beta, this is equal to pi by 4. Okay, so the value of alpha plus beta is equal to pi by 4, and this is our final answer. So I hope you will understand. Okay, and if you have any doubt, then you can ask. Otherwise, you can write in chat section. Clear. Okay, do you have any doubt? I hope you have no doubt. Okay, so that's all for today's lecture. Thank you for your attention. Okay.
Hello everyone. In today's lecture, we are going to learn about current electricity, and this is theory part second. This is our disclaimer. So in today's lecture, we are going to learn about first electrical energy and power. Then we will learn electric cell. After that, we will study about the internal resistance of a cell. Then we will study the concept of potential difference and EMF of a cell. Then we will discuss combination of cells in series and parallel. After that, uh, we will discuss about Kirchhoff's laws and their applications. Then we will discuss junction rule. Then we will discuss loop rule. Then we will discuss Wheatstone's bridge. And last, we will study meter bridge. Okay, meter bridge is a special case of Wheatstone bridge. Okay, everyone. So these are the concepts of the today's lecture, which we will discuss one by one. The first is electrical energy and power. So whenever electric current passes through a conductor, it heats up after some time. Okay, and this effect is called the heating effect of current or Joule's heating effect. You must have seen this phenomena, for example, when we use a heater in winter. What happens? As soon as electric current passes, the heater heats up. Yes or no? And other devices also heats up, such as a mobile charger when we plug it in for charging. The charger also heats up and the mobile also heats up. And we know that heat is a also form of energy. And we also know that according to law of conservation of energy, energy can neither be created nor be destroyed. It can be only converted from one form to another. So, where does this energy come from? The electric current itself supplies that energy, which is electrical energy. Okay. Now, when electric current passes through a conductor, the object heats up. Why? Think about it. Because one form of energy is converted into another form, and this conversion occurs in the form of heat due to the electric current passing through the conductor. Okay, every conductor or material has a property which we call resistance. So to overcome resistance, electric current has to do some work, due to which the form of energy changes and the electrical energy that the current was carrying converts into the heat energy. Okay, let's see the expression for this energy. So the formula we have, H is equal to I square RT joule. Okay, so to convert joules to calories, we know the relation, that is 1 calorie is equal to 4.18 joule. Okay, so here we have a I square RT joule. Okay, this is the heat energy. If we want to convert it in joule, so it becomes I square RT divided by 4.18. Okay, so solving this calculation, you will be get heat energy in the in the unit of calorie. Okay, everyone, let's talk about power. What is power? Power is the rate at which energy is consumed. Okay. So if we talk about the source of EMF, so we can say source of EMF means battery cell or AC generator, DC generator. Okay. So the full form of EMF is electromotive force. So the rate at which a source of EMF works to maintain the effect of current in a circuit is called the electric power of the circuit. Okay everyone. So to calculate the power, we have a formula. Its formula is P equal to VI. This means that if we apply V voltage across a conductor or resistor, some current will develop in it. Okay. And if we talk about the SI unit, so we can say SI unit of power is watt. So if we talk about the other expressions for power, so we can say P equal to I square R. Okay. So how much work will be done here? I square RT. And when we divide this by time, will cancel out and only I square R will remain. So that same expression is written here. Okay. So now look here, uh, is the expression for joule flow of heating, I square RT. So P equal to V square by R. And the interesting thing is that if you remember Ohm's law, which is V is equal to IR. Okay. V is equal to IR. So here we know Ohm's law, V is equal to IR. Now if we use this, substitute IR for V in P. Okay. So P equal to Vi, then P equal to IR into I will become P equal to I square R. Clear? So now look, from P equal to Vi, we can also derive P equal to V square by R. This one. P equal to V square by R. How? P equal to Vi. Now find the value of I from V equal to IR. So I equal to V by R. Now substitute this. So P equal to V into V by R. Okay. So it becomes P equal to V square by R. If V and I are given in this question, any question, we will use P equal to Vi. If I and R are given, we will use P equal to I square R. And if V and R are given, we will use P equal to V square by R. So these three formula are very important. P equal to Vi, P equal to I square R, P equal to V square by R. Okay everyone? Clear? The next concept is electric cell. So what is an electric cell? Tell me. Electric cells are used, for example, in remotes. Okay. Or we can say it is the most commonly used cell in remotes, or cells are also used in small electronic devices like speakers, mobile devices. Okay. So what is a cell? An electric cell is a device that maintains a continuous flow of charges with the help of chemical reactions. Okay everyone? inside the cell, look at it, inside this cell we have two electrodes which are made of different materials. Suppose we take a beaker, okay, and fill it with an electrolyte such as salt. Look at figure, this one is electrolyte. The simplest salt we know, which we use daily, is NaCl, sodium chloride. Okay, so a cell can also be made with its help, but when we make a cell with it, its efficiency is very low. So its use is very limited. Okay, everyone. Different types of cells are coming out. A lot of research has been done on this, and only then have better cells been made. Basically, we need an electrolyte here. It means ions on which both positive ions and negative ions are present. Okay, so then we insert suitable metals into it, and these metals create a potential difference across these electrodes. Okay, across these electrodes, so there will be a potential difference, so which helps maintain the flow of charges within the circuit, within this circuit. Okay, this means you can see due to the potential difference, positive charges will accumulate on one side of this metal rod, one side of this metal rod, and negative side will accumulate on the other side. And because of this, the flow of charge will start from here to here. Okay, here to here. So flow of charge is what we call current. So this battery works such that we have a container filled with electrolyte. Okay, we use metals which we call electrodes. Two types of electrodes are formed: a positive electrode and a negative electron. Okay, everyone. So this is the all about the electric cells. Next is internal resistance of a cell. So when current is drawn from a source, the potential difference between the two terminals of the source will be V equal to E minus IR. Okay, and you can understand it this way: the cell we buy, like a button cell or a TV cell, the cell used in a TV remote, has a marking on it. It says 1.5 volts. Okay, so this is the EMF which we represent simply by E. It means the cell can provide a maximum of this much voltage, nor more than it. That is, it's an ideal thing that this cell can provide it a potential difference of 1.5 volts. This is the maximum value. But when you actually measure it, the value comes out slightly less than 1.5, such as 1.45 or 1.48. Some such value might come, or it could be around 1.40. So suppose we take 1.4, then the voltage we get instead of 1.5 is 1.4. It means when we actually measure it, we get 1.4 volts. So this is the represented by V. Okay, so this V represent the potential difference which is in working condition. It means when current is flowing through it, the voltage across the terminals at that time is that value, and EMF is the maximum possible value that a cell can provide when no current is being drawn. Okay, so when no current is flowing through it, we get the maximum potential difference across its terminals. So the potential difference across A and B will be, look at here, A across A and B. So VA minus VV equal to E minus IR. So three special cases are possible. If we talk about the first case, if the current flows in opposite direction, as in case of charging of battery, then V equal to E plus IR. Okay, so now let's understand how this came about. So to charge a battery, we need an external charger whose voltage should be stronger than the battery's EMF. Okay, so we are actually forcing the current to move backward into the battery. Now the battery's internal resistance will work against the external charger. Okay, let's understand this with an example. It's like we are pushing a heavy box up a ramp. Now in this we not only have to overcome the weight of the box but also its friction. Now if we need to find the total voltage required from the charger, then the voltage required to overcome the battery's EMF is E, and the second voltage required to push the current through the internal resistance is IR. So the charger will have to provide V equal to E plus IR voltage, and the terminal voltage V should be greater than the battery's own EMF. The second case, V equal to E. If V equal to E, when the current through each cell is 0. And the third case, when the cell is short circuited, then V equal to 0. So because in this circuit, I equal to E by R, or we can say E equal to IR. Look, when E equal to IR, as soon we say here E minus IR equal to 0. If we compare with this equation, then V equal to 0, okay, is coming. So whenever a circuit is short circuited, the voltage becomes 0, and at this time the current is at its peak. So the value of current becomes maximum. Therefore batteries are made such that their internal resistance has such a value that if a short circuit occurs in any way, a fire does not break out. Okay, so the batteries used in homes have their own internal resistance kept a bit higher, so that if a short circuit accidentally occurs, the current value does not become too high and fires do not occur because the current would become very high. Now we will summarize these. V equal to E minus IR will be when V is less than the EMF. The second case is when V is greater than E, like the case of charging a battery. In that case, V equal to E plus IR. And the last case, if V equal to E. So V equal to 0 means in short circuit and current will be infinite. Okay everyone, any doubt here? Yes or no? Now we will study the cells potential difference and EMF. So electromotive force, or we know EMF, is the terminal potential difference of a cell when the cell is in an open circuit. Okay, so as I just told you, EMF is across the cell. Suppose there is a cell, okay, and this cell has its own internal resistance. So the potential difference obtained across it when the circuit is open, meaning when no current is flowing through it, the voltage across the terminals at that time is what we call EMF. So EMF is when the cell is not supplying any current to an external circuit. But when the cell supplies current, the voltage across the terminals at that time is called terminal voltage or terminal potential difference. Okay. If E is the EMF of the cell and R is its internal resistance, and an external resistance capital R is connected with the cell. Okay. Then now look, the EMF of the battery or cell is E. Okay. Internal resistance is R and external resistance is capital R has been connected with it. So now the current that flow within in this circuit, its value will be I equal to EMF divided by capital R plus R. Okay. Terminal potential difference V is equal to IR, and the value of current is E divided by R plus R. So the value of terminal potential difference will be V equal to IR, which is equal to ER divided by R plus R. Okay everyone. Now we look at the internal resistance of the cell. We know the equation that is E equal to V plus IR. So E minus V equal to IR will become, upon rearranging, now find I from here. So it will be we can say E minus V divided by R equal to I, and the value of small r will be E minus V divided by I equal to R. Now we take V common from the numerator, so the equation will become E by V minus 1 divided by E by V minus 1 into V by I equal to R. And according to Ohm's law, that is V equal to IR, so V by I will be equal to R. The equation formed is E by V minus 1 into R is equal to small r, and the terminal voltage will be greater than the cell's EMF when the cell is charged, and then the value will be V equal to E plus IR. Okay. Now we will study the concept of combination of cells in series. Then we will discuss combination of cells in parallel. Okay. When we connect cells, a battery is formed. You must have seen that in a TV remote or any other remote, sometimes we use more than one cell. So what is the purpose of the cell? We are using to increase the voltage value. If the purpose is for the voltage to remain the same and last longer, then we connect cells in parallel. That is, we make a battery by connecting cells in different ways. So grouping can be of two types. One is the series grouping and the other is parallel grouping. Okay. So a group of cells is called a battery, and common grouping of cells is series grouping or parallel grouping. So when we talk about series grouping, then if all cells are connected such that current flows in the same direction, okay, or we can say in a single direction. Look at here, in a single direction current flows from here to here. Okay. For example, if we connect cells such that the negative terminal of one connects to the positive terminal of another, then its negative to the next positive and so on, then this combination is called series combination, or we can say series grouping of cells, and this forms a battery. If the EMF of the first cell is E1 and the second cell is E2, the third E3 and so on from E4 up to En. So then the equivalent EMF will be E equivalent is equal to E1 plus E2 plus E3 and so on. This is its resultant E equivalent. Okay everyone. If one or more cells are joined in such a way uh, that we need to reverse the direction of current supply, then we will have to take the EMF of those particular cells as a negative when we are calculating their equivalent EMF. So now what happens here is that when we combine so many cells, each cell has its own internal resistance. Okay, then we can find an equivalent internal resistance for the entire combination. Why? Because we need to understand that here is a internal resistance of this battery. So the internal resistance of all these cells will add up in series, and the equivalent resistance of a series combination is R equivalent is equal to R1 plus R2 plus R3 up to Rn, and this is the same thing you have done. How the EMF of this battery was obtained by adding the EMF of the cells, and their equivalent internal resistance will be R1 plus R2 plus R3. So if you have n cells and each battery has an EMF E and internal resistance small r, then the equivalent EMF you will get will be E equivalent is equal to Ne, and equivalent internal resistance will be R equivalent is equal to Nr. Okay everyone, any doubt here? If you have any doubt, please ask. Yes, Karthik, Varsha, VK. Any doubt? Yes or no? Now we will talk about parallel grouping. Okay, everyone. So, in the parallel grouping, what happens is if the positive terminals of all cells are joined at a single point, it means all positive terminals of the cells are to be joined together and all negative terminals are also to be joined together. Okay, so this combination that is formed, we call it a parallel combination. Now in parallel combination, think that here along with the battery there is also internal resistance. So we have two tasks. We need to find E and E equivalent and R equivalent. All right. So look, when resistance is connected in parallel. Okay. So we have formula to find for finding equivalent resistance. So 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on, plus 1 upon Rn. Once you have found R equivalent, now we come to this equation which states E equivalent upon R equivalent, which is equal to E1 upon R1 plus E2 upon R2 plus E3 upon R3 up to En upon Rn. Okay, so first find R equivalent, then by putting the values, E equivalent will be found. Suppose you have n cells and all have EMF E and internal resistance small r. All these cells are connected in parallel. Okay, so R equivalent will be R divided by n, small n, and the equivalent EMF will be equal to E. All these important formulas are very important. Okay, so please note down. Next is Kirchhoff's laws and their applications. So there are many circuits that cannot be broken down into simple series or parallel combination circuits. Why? Because if that were the case, solving things would be very easy, but that is not the case. Our circuits are quite complex and we cannot solve them using simple series or parallel combinations. Okay, so as you can see here in the diagram A and B, there are two circuits in front of you. Okay, both are complex circuits. Okay, yes or no? There are two batteries in the other three batteries. In the first E1 and E2, E1 and E2. In the second one, E1, E2 and E3. In the first, there are R1, R2 and R3, and in B, resistances are R1 to R4. Also, and R4 is also present here. Okay. So when such a circuit comes before us, we have to change our approach and some laws. We will call Kirchhoff's laws. There are two laws on this. One is Kirchhoff's voltage law, which we also call KVL or loop rule or mesh rule. Okay, and the second is Kirchhoff's current law, KCL or junction rule. Okay, everyone, and we will discuss both. So first we will talk about the junction rule. So at any junction, the algebraic sum of currents is 0. It means summation means sum of all currents at the junctions is equal to 0. We write this mathematically like summation junction I equal to 0. Okay. Now look at the figure here. In this figure, this is very important concept, so please listen carefully. Look at the figure. The direction of I1, I2, I3 and I4. Okay, so the direction of I1 is like this. We can say incoming, incoming. Direction of I2 also incoming. All direction of I3 outgoing and I4 outgoing. Okay. Now all these currents values are going from one point and coming to same point. This point is what we call a junction. A junction. This point. Okay. This is a junction. So the total incoming current is equal to total outgoing current. This is our junction rule. It means I1 I2 equal to what? I3 I3 plus I4. Yes or no? I1 plus I2 equal to I3 plus I4 according to junction rule. So the this our junction rule. So if we take its algebraic sum, that is I1 plus I2 minus I3 minus I4, means if we consider incoming current as a positive, so I1 plus I2, and if we take a outgoing current as a negative, so I1 plus I2 minus I3 minus I4 equal to 0. Okay, so we can write this I1 plus I2 plus equal to I3 plus I4. Okay, so the junction rule is based on the conservation of electric charge. This is very important concept. Junction rule based on conservation of charge. Next is loop rule. Now we will study the loop rule. The algebraic sum of potential differences in any loop, whether it contains associated EMFs or resistive elements, should always be equal to 0, meaning summation delta V around any closed loop equal to 0. This law represents the conservation of energy, meaning energy always be conserved. Now we understand this mathematically. So there is a circuit in which we apply Kirchhoff's law. Okay, everyone. So look at the figure. Look at the circuit at a junction A. At a junction A. This one. This is a junction A. Okay. The current leaving is I1 plus I2. Yes or no? I1 plus I2. And the entering is I3. So this one is I1, I2, and incoming current is I3. Alright. So according to junction rule, I3 is equal to I1 plus I2. It means total incoming current is equal to total outgoing current. Yes or no? For the loops AH, uh, DCBA and AHDEFGA, the loop rules give 30I1 minus 45 plus I3 plus 40I3. So when we consider both these loops, we will apply KVL to them. Okay, and we will get two equations. So let's see how. First, understand how to apply KVL. Listen carefully. What to do? It's very simple. So whenever you see such a tough circuit, consider a junction like A. Okay, consider a junction. At least one current should be incoming at that junction, and at least one should be outgoing. Okay, so you can draw current in any direction. It's up to you. That only condition is that there should be at least one incoming and one outgoing current. Okay, so we applied this thing here first. As soon as we applied KCL, we found that we kept one incoming current, incoming I3, and made two outgoing I1 and I2. So we got I1 plus I2 equal to I3. You never need to worry whether you have to taken the correct or incorrect direction of current. Okay, only while applying KCL. So when drawing the direction of current, one thing to remember is at the junction there should be at least one incoming current and at least one outgoing current. Okay, no matter which direction you choose, when the answer comes, everything will be correct. So this is the first point. And the second point is that when we consider a loop to apply KVL, we will start moving in the direction of current, starting from away from the battery, never start near the battery. Okay. So in this loop away from the battery, we started moving from near the 30 ohm 30 ohm, this one 30 ohm resistor. Then what will be the voltage drop across it? It will be 30 I1. So we will write 30 I1. So we have written 30 I1. Okay. Then after that, keep moving forward. Okay, keep moving forward like this. Keep moving forward. So you find the negative terminal of the battery. All right, negative terminal of battery. Then you will write minus 45 volt. Okay. Then move forward. Just pay attention to resistance here. This one 40 ohm resistance. Yes or no? If the direction in which you are moving is same as the given direction of current, then you have taken the same direction for current as your movement. So when your direction of movement and the direction of current are same, you will write I3 into 1 ohm. Okay, that is I3. Then further 40 into I3 is written and you will equate this to 0. Okay, so the equation formed is 30 I1 minus 45 plus I3 plus 40 I3. So this is the all about loop rule. The equation become this one 30 I1 minus 45 plus 41 I3 equal to 0. Now similarly using the same steps, we will form an equation by applying the loop rule on loop AHDEFGA. So the equation obtained 30 I1 minus 20 I2 minus I2 plus 80 equal to 0. Then the further equation will become 30 I1 minus 21 I2 plus 80 equal to 0. Alright. Now we will study the concept of the Wheatstone bridge. This is very important concept for the exam. Alright. So a Wheatstone bridge is a device used to accurately measure resistance. It is an arrangement of 4 resistances which gives us an equation from which we can find the value of one resistance in terms of the other 3 resistances. Okay. Therefore, the Wheatstone bridge is quite useful for accurately measuring any resistance. Now let's see how it works, which equation is used and what the process is. Let's see. So let's assume look at here. Let's assume that we have 4 resistances P, Q, R and S. Okay, we have connected 4 resistors like this, one after another, then like this, then like this, then this and then this. Okay, like a quadrilateral. Look at here in this figure. Here at points A, B, A and C, at point A and C, where A and C are in this bridge, we have connected a battery, and across the other 2 points B and D, we connect a galvanometer. Okay, this is the galvanometer. The function of the galvanometer is to indicate whether there is a current in this arm or not. Now let's see how it works. So so we have considered four resistances and fixed them in a quadrilateral shape in these four arms. So the bridge is considered balanced when the galvanometer shows zero deflection. Okay, so when you close S1 switch, this one, it means when current starts flowing from here, at that time you have to set the values of these four resistances such that deflection on galvanometer becomes zero. So when the deflection on it becomes zero, you have completed the circuit here, and even after that the galvanometer still shows a zero value in the arrangement of these four resistors. So the entire Wheatstone bridge is in a balanced condition. Okay, so when it is a balanced condition, we say that P by Q equal to R by S. Okay, we call this the balance condition of the Wheatstone bridge. And now you can see that from this condition, if we don't know the value of P and know the values of R, S and Q, then what will we do? We will try to find the balance condition, connect P, then change the value of Q, R, S such that zero deflection is obtained on the galvanometer. So as soon as this happens, we will get the condition P upon Q equal to R upon S. Then we will find the value of P by putting the values of R, S, Q. That is, at the balance condition, the potential difference between points B and D is 0, meaning VB minus VD equal to are equal. Okay, VB, potential at B and potential at D are equal. Now we will discuss about meter bridge, which is a special case of the Wheatstone bridge. Okay, so this is the simplest form of the Wheatstone bridge, and it is specifically useful for comparing resistances more accurately. It gives us an easy tool for comparing resistances. The Wheatstone bridge has become our principle, and with its help, finding resistance take quite some time. Whereas the meter bridge, by making a slight change in construction, makes this task very easy. So the construction of the meter bridge is shown in the figure. Okay, you can see it there. What happens in this is that there is a 1 meter long resistance wire. Okay, 1 meter long resistance wire. So which is clamped between two metallic strips that are bent at right angles. Okay, like this one is, and this one and this one, right angles. Okay, so look what happens. There is a resistance wire here. Okay, so the metal strip like this, look at the figure. Then there is another metal strip in the middle. So we get two gaps here. Okay, in these two gaps we connect a known resistance and an unknown resistance, like this, known resistance and R and S. There are two resistances, and a galvanometer is connected from point P to point T as shown in the figure. Okay, so we can say galvanometer is connected from point B to point D here, and the point is not fixed. It is connected to a jockey. What is jockey? A jockey is a device which where a wire can be connected at one end and it has a knife edge on one side. A wire is connected on one side and this is connected to the galvanometer. Okay, and this point is connected to point B. This one connected to point B. So we can slide this meter bridge wire from here to here. Okay, here to here. Then we need to keep in mind that, what kind of resistance this 1 meter long meter bridge wire has. It should be made of the same material, and the cross sectional area should be also be the same. This means if the wire gets damaged somewhere, becomes thin somewhere or thick somewhere, then we will not be able to use the meter bridge correctly to achieve the Wheatstone bridge condition. Okay, and then it will be useless. So uniform thickness means that the cross section of wire should be the same everywhere and it should be made of the same material. Okay everyone, clear? So there are two gaps and a galvanometer is connected across BD with the help of a jockey, and a cell is connected across AC. So after making the conditions, the jockey is moved along the wire and its null point is found. Okay, and the wire used should be of uniform material and cross section. If we connect a resistance R and R and the value of R is unknown, the value of S is known. Okay, then we can write R upon S is equal to L1 upon 100 minus L1. Now what is L1? We have taken the value of R as unknown and the value of S as known. Then we moved the jockey back and forth on this wire. Because of this, suppose we find a point at length L1 from A side where zero deflection is occurring. So we just get this condition, R by S is equal to L1 divided by 100 minus L1, which gives us R equal to S into L1 divided by 100 minus L1. Okay, L1 is the length that we get when this balance condition occurs. In this way we use the meter bridge. Okay everyone, now we will summarize what we studied in today's lecture in a few points. Electrical energy and power. Electrical energy is energy that flows due to electric charge and it is measured in joules. Electric power is the rate, meaning the rate at which this energy is used or produced, and SI unit of power is watt. So an electric cell converts chemical energy into electrical energy through electrochemical reactions and provides a voltage source. Then internal resistance is the resistance inside the cell that impedes or obstructs the flow of current, which further affects the efficiency or voltage output of the cell. Then the cell's potential difference and EMF are the work done to move a unit charge between 2 points. EMF is the maximum potential difference of a cell will provide when no current flows. Then combination of cells in series or and parallel. In series, the total voltage is the sum of individual cells while the total current remains the same. And in parallel, the total voltage remains the same. Then Kirchhoff's laws and their applications. Kirchhoff's law includes the junction rule based on conservation of charge at a junction, and the loop rule, total voltage around a closed loop is zero. So these are the fundamental in analyzing complex circuits. Then junction rule, according to junction rule, total current entering a junction is equal to the total current leaving it. This ensures that electric charge is conserved. Then a loop rule. So according to the loop rule, the sum of the potential differences in a closed loop must be equal to 0, which balances voltage rise and drop. Then Wheatstone bridge. A Wheatstone bridge is a circuit used to measure unknown resistance by balancing two legs of the bridge circuit. And last, meter bridge. So meter bridge is a practical implementation of the Wheatstone bridge by using 1 meter long wire for accurate resistance measurements. Okay, thank you for your attention. Now we will discuss some practice questions based on these concepts. So are you ready for the practice question, everyone? Yes or no? Hello students. Now we will solve some practice questions based on current electricity. Okay, this is our disclaimer. Here we will solve some practice questions based on current electricity. So the first question, or we can say 10th question of the current electricity: when an electric heater is switched on, the current flowing through it is plotted against time, taking into account the variation of resistance with temperature. Which of the following best represents the variations? So let's understand the question first. So in this question says that when an electric heater is switched on, the current passing through it, okay, and it is plotted against time t. So keeping in mind that resistance varies with temperature, now we need to tell which of these graphs best represents this variation. Okay, that is, we have an electric heater and it has been switched on. So the current flowing through it has been plotted against time. That is, from the moment we switched on the heater up to a later time. So the variation of current corresponding to that time has been plotted here. Okay, one thing has been considered, that Resistance varies with temperature, which means when we switched on the current develops, due to which a heater starts to heat up. Okay, so when the heater starts to heats up, it's obvious that the temperature increases, resistance will also increase, specifically in case of conductors or metals. Yes or no? So based on this information, find out the correct one graph. Okay, please solve everyone. Which one is correct? A, B, C or D? You have some time. Please solve. Which one is correct? B option. Okay. Anyone? Yes, please solve. So the correct option B. Okay. Let's see the solution. So look, the filament will attain its steady state resistance after some time. Okay. How? When heater's filament operates, its resistance increases with temperature. Filaments are usually made from materials like nichrome, which have a positive temperature coefficient resistance. This means that when the filament is hot, its atoms vibrate more vigorously, which makes the flow of free electrons difficult. And due to this, the resistance increases. Okay, so at room temperature, when the filament is cold, the resistance is considerably low. At operating temperature, so steady state, the resistance is significantly higher than that cold resistance. So when you switched on the heater, the initial current is high, but uh, as it heats up, resistance increases and the current stabilizes. So when the heater is switched on, okay, listen carefully. Initially, it draws a larger current, which is called the increase current. So the reason for this is that at that time the filament is cold at room temperature and its resistance is very low. Okay, so metals have the property that their resistance increases as temperature increases. So as soon as current flows, the filament quickly heats up and its resistance rapidly increases. So with the increase in resistance according to Ohm's law, which is V equal to IR, the current automatically falls and reaches a steady state value, which is drawn during normal operation. So in the cold state, high current flows due to low resistance, and in the hot state, a lower steady state flows due to high resistance. Okay, so this phenomena is based on the basic principles of physics. So when the heater is switched on, the filament's temperature is low at room temperature, and due to this, according to temperature, electrical resistance is very low. Okay. So we know the formula of Joule heating effect. H is equal to I square. H is equal to I square RT. So with increase in temperature, resistance of filament material automatically increase, and the value of current decreases until the settles the steady state operating current. This high initial current surge called the ingress current. So B option is correct. Next question. Two bars of radii R and 2R are kept in contact as shown. Look at here. Okay. So an electric current I is passed through the bars. Which of the following is correct? So here we need to calculate the heat produced in both bars. So calculate the electric field for both, calculate the current density, find the relation between current density in AB and BC, and also calculate the potential difference. Okay. So which option is correct based on this information? Option A, heat produced in BC is 4 times the heat produced in bar AB. Option B, electric current in both halves is equal. Option C, current density across AB is double that of across BC. And option D, potential difference across AB is 4 times that of across BC. So which one is correct? Please solve this question everyone. You have some time. Okay. Please solve. Which one is correct? A. Anyone? Which one is correct? Okay. Please try to solve. So the correct option is A. Okay. Let's see the solution. So as current flowing through both bars, the same current will flow through both bars. Okay. Now if we talk about uh, Joule's law of heating here, since current is flowing in both, if we try to calculate the heat, then because of current is the same in both, heat will directly depend on the resistance. So the formula H is equal to I square RT, or we know H is directly proportional to R. This means the bar with higher resistance will also have higher heat production. Okay. So if we look at the heat produced across AB and the heat produced across BC, then HAB by HBC is equal to RAB by RBC. So this will be look now, because now the formula of resistance is R equal to rho L by A, meaning R is inversely proportional to A and R is inversely proportional to A here. Okay, and if we break this down a bit further, then A equal to pi r square, it means the square of the radius. So we can say resistance is inversely proportional to square of the radius. So cross sectional area is radius square, so the resistance become inversely proportional to R square. So this is what we have used, HAB by HBC equal to RAB upon RBC. Now for RAB, the resistance we are going to calculate will come with the help of radius of the cross sectional area, which is 2R. So it will be 1 upon 2R whole square, and similarly for RBC it will be 1 upon R square. So solving this, you will be get 1 upon 4. Okay. So the same thing is written here, HBC equal to 4 times of HAB. Next question. Which of the 4 resistances P, Q and PQ, R and S generates the greatest amount of heat when a current flows from A to B as shown in the figure? So we will use Joule's heating of effect to solving this question, and we know the formula H is equal to I square RT. Okay, so please solve this question. Given options: option A Q, option B S, option C P, and option D R. Please solve everyone. You have some time and tell me the correct answer. Okay. Which one is correct? You have to find out the how much heat is being produced across each resistor, and you know the formula H is equal to I square RT. Okay, please solve this question everyone. This is very simple question. So the correct option is B. Okay, let's see the solution. So here we know that when there is a such a parallel combination, the current will be less where the resistance is higher. Okay, this means we can say that current is inversely proportional to resistance. So now what we will do, so suppose current is coming from here, okay, from A side. Okay, So current coming from A, then it will divide into two parts as shown in the figure. Look at here in the diagram. Current is coming from A and divides into two path. Okay, because there is a two path. So two paths. So I1 current in this path. Okay, and I2 in this path. Clear? Now what will be I2 be? Okay. So I2 will be equal to 6 divided by 3 plus 6 into I, which is 2 by 3 into I. Now this current that we have calculated is not something different. We have applied the concept that if this is resistance, then the current will be inversely proportional to resistance. Okay, so only this concept has been used, and this is how the this result has come. So look, if we make the equivalent circuit, then the upper resistance will be 6 ohms and the lower one will be 3 ohms. Okay, how much? 3 ohms. So now if we look here, okay, so at what the voltage drop across it will be. So if we need to find the find out this, suppose I is coming, then how much current will go this way and how much will go the other way. Okay, so we can say when there is a such case where resistance is connected a parallel combination, we need to find the how much current will into this arm and how much current into other arm. Okay, so here suppose I1 will be equal to 3I divided by 6 plus 3, which is equal to I divided by 3. So look, this is a fraction, resistance upon uh, resistance is a fraction that tells how much current will go here. So the current value for I1 is I divided by 3. So we have to use concept that where resistance is higher, current will be lower. So now we know the formula of power rate in 2 ohm of the upper series. So it will be 2 into 1 by 3 into I whole square. Solving this, you will be get 2 by 9 I square. Similarly, look across 4 ohm as well. So the current flowing through 4 ohm is also uh, I. So I by 3. So it will be 4 into I by 3 whole square, which is equal to 4 by 9 into I square. Similarly, for the power rate of 1 ohm in lower series, so it will be 1 into 2 by 3 I whole square, which is equal to 4 by 9 into I square. And for power rate of 2 ohm in lower series, 2 into 2 by 3 I whole square, which is equal to 8 by 9 I square. Okay, so here the maximum heating we produce is 8 by 9, right? So the greatest amount of heat generated is by S. Alright, so B option will be correct. Next question. A DC source of EMF E1 equal to 100 volt and internal resistance R equal to 0.5 ohm. A storage battery of EMF E2 equal to 90 volt and an external resistance R are connected as shown in the figure. So for what value of R no current will pass through the battery? Okay, so you have to find out the resistance value. Given options: option A 5.5 ohm, option B 3.5 ohm, option C 4.5 ohm, and option D 2.5 ohm. So which one is correct? Please solve this question, everyone. Find out the correct one. Which one is correct? So the correct option, C. Let's see the solution. So given E1 equal to 100 volt, equal to 0.5 ohm internal resistance, and E2 equal to 90 volt, and external resistance, that is R here. Okay. So we need to consider this, and only then will not no current flow through the middle battery E2. And when we take this condition, the circuit will simplify. So it will become, look, if the voltage across is 90, then we look at this value of current, because now this has been become a series circuit. So it will be 100 divided by R plus R equal to 90 by R. So just put the values. You will be get 10R equal to 9R plus 4.5 ohm. So R is here, which be 4.5. Okay. So there is a one more method. So just use here mass rule in this circuit and this circuit. Okay, in opposite direction. Then you will be get the correct one answer. Okay, everyone. Next question. Two batteries of EMF E1 and E2. E2 is greater than E1, and internal resistance R1 and R2 respectively are connected in parallel as shown in the figure. Okay. So here we have to find out the correct one. Given options: option A, two equivalent EMF equivalent of the two cells is between E1 and E2, that is E1 is less than E equivalent and less than E2. Option B, the equivalent EMF equivalent is smaller than E1. Option C, the E equivalent is given by E equivalent equal to E1 plus E2 always. And option D, E equivalent is independent of the internal resistance R1 and R2. So which one is correct? Please solve this question. You have some time. Okay. Which one is correct? A, B, C, or D? A. So the correct option is A. Okay. So the equivalent EMF of this combination is given by E equivalent is equal to E2 R1 plus E1 R2 divided by R1 plus R2. Okay. Here we use direct formula. So from this we know that E2 is greater than E1. So when the equivalent E is calculated, it will be less than E2 and greater than E1. Okay, and its value will be equivalent between 2. So let's move on the next problem. Next one is, in the circuit shown, battery, ammeter and voltmeter are ideal, and the switch S is initially closed as shown in the figure. When switch S is opened, match the parameter of column first with the effects in column second. So there is a column 1 and column 2. Okay, you have to find out the match column 1 with column second and find out the correct option. Okay, so please solve this question. What is the behavior of current here, and what is the behavior when the switch is closed? If you understand this, you will be able to solve this question. Please solve, give us some time. So the correct option will be here, we can say A. All right. So A option will be correct. When switch S is opened, uh, then right side resistance R, which was short circuited earlier, contributes to equivalent resistance. Okay. Hence, equivalent resistance across the battery increases, power dissipated by the left resistance R decreases, voltmeter reading decreases, and ammeter readings decreases. Okay, so A option is correct. Next question. This is very simple question. So question in the circuit shown the figure, the point E uh, is ground point F is grounded. Which of the following is wrong statement? So listen carefully. Here you have to find out the wrong statement. Given options: option A, D is at 5 volt. Option B, E is at 0 potential. Option C, the circuit in the current in the circuit will be 0.5 ampere. And option D, none of the above. So which one is correct? Please solve this question, everyone. You have some time. Okay, please solve. So the correct option is B. So what happens here is that if we consider the effective EMF of this entire circuit, so after grounding, our effective EMF will be 10 volts and 3 volts. So if we only consider the EMF, we have disregarded the resistance because the source of EMF is same. Okay, and how are these two connected? So its positive is with its positive, and they will be cancelling each other's effect. Therefore the effective EMF of the circuit will be 10 minus 3 equal to 7 volt. All right, and total resistance of the circuit, 2 plus 5 plus 3 plus 4 equal to 14 ohms. Now how much current will flow in the circuit? If we disregarded that it is grounded, how much current will flow in the circuit? So the total resistance divided by equivalent EMF. So 7 divided by 14, it means 0.5 ampere. And potential difference between A and D is equal to 0.5 into 10, which is equal to 5 volt. And potential at D, 10 minus 5 equal to 5 volt. Okay. And potential at E, 5 minus 3 equal to 2 volt. So when we were given in the option B that E is at 0, then when E is at 0, there should be no potential drop across the resistance, where actually E is at 2 volts. Okay. Here and there will be a voltage drop across the resistance because it is grounded here. Only then it is 2 volts here, only then it is we can say E's cannot be at 0 potential, as there be potential drop at E. This means option B states that there is a no potential at E. Okay. Clear? That's all for the today. Thank you for your attention. In next lecture, we will discuss about moving charges and magnetism. Okay. Thank you for your attention, everyone. Thank you.